मीट का इसमें चल रहा है कुछ नहीं चल रहा आवाज उधर जाएगी पूरी, इधर भी पूरी आएगी, मेन आवाज ज्यादा बढ़िया ਇੱਥੇ ਆਏਗੀ ਜਾਂ ਆਨਲਾਈਨ ਜਾਏਗੀ? ਮਤਲਬ ਇਹਦੀ ਮੇਨ ਜਿਹੜੀ ਮਾਈਕ ਦੀ ਆਊਟ ਹੈ, ਮਾਈਕ ਦੀ ਆਊਟ ਇੱਥੇ ਦੇ ਸਪੀਕਰ ਨਾਲ ਅਟੈਚ ਹੈ ਜਾਂ ਫਿਰ ਉਹਦੇ ਜਿਹੜੇ कैमरा रिकॉर्ड करेगा, मतलब सेकेंडरी वॉइस जाएगी उधर, ऑनलाइन सेकेंडरी वॉइस है यार। एक केबल ले लो यार, कितनी बड़ी गल है, वो जो केबल कट के लाया है यार, प्रॉपर जाएगी। अच्छा अच्छा, एक स्पीकर अच्छा आवाज दे चलेगा लोड सिस्टम का मतलब ये वो बाकी वो मेन जो लगा है सिस्टम तो जरूर से हमने कर लिया वो भी वाले बिना भी कोई ऑनलाइन करना। अच्छा वो 2 है कितने तक इन लोगों ने बस इधर चलो तीसरा ट्रैक को लेकर वो भी बैटरी जो बैटरी प्रोफेसर अंदर शो हो गया
हमें वही है कैमरे से डेमो आ रहे
सारा वीडियो चेक करा था करके देखो दिखा
नहीं बढ़िया है नहीं यार नहीं चल रहा मैं तो बोल लेने किसी मैं
कराना होगा सब कुछ
अच्छा
भरावा उन्हें घर में पटा जैकेट पा के उन्हें नहीं पप्पी है जेडी
हिंदी में घुसा दिए
हेलो किसको तो बोल जाएगा
हिंदी में क्या है
हर जगह
अरे वो तो ठीक है
मतलब मैं पहले कोऑर्डिनेट करूंगा वही सूट करके प्रेजेंटेशन मेरा पता ना वो सबसे अच्छा है वो तो इसमें बोल
नहीं जा रही यार
ये मालूम है रोज उसमें कितनी एक उसमें 10 होना है अच्छा 12 है टोटल दो रखवा देंगे दो रखवा देंगे
नहीं यार कौन देख रहा है इसको बाहर वाला कर दूंगा खाने के लिए मतलब कुछ नहीं सकते पानी का बॉटल कितनी मत और ये
हेलो
वाइब्रेशन सेकंड मैं नीचे कौन सा कॉल मैं कब से नीचे तो बैठे हैं मेरे बोले तब के नीचे ही बैठा नदी
इसका इसी का कौन होगा इसका थोड़ा चलवा दो या फिर नहीं
बंद कर दिया मतलब बिजली वालों ने कर दिया
थोड़ा बोलना है
जगह हाँ ਬੰਦਾ ਬਾਹਰੋਂ ਆਇਆ ਸੀ ਇੰਟਰ ਜਾਣਾ ਕਲਾਸ ਕਰਨ ਬਾਹਰ ਵੀ ਜਾਣਾ ਬੰਦਾ ਇਹਨੂੰ ਗਲੀ ਚ ਲਵਾਇਆ ਇਹਨੂੰ ਫੋਟੋ ਨਹੀਂ ਪਾਈ ਦੀ ਜਿਹੜਾ ਲਾਇਆ ਆਖਰੀ ਵਾਰ ਦੀ ਜਿਹੜਾ ਲਾਇਆ ਯਾਦ ਕਰਨਾ ਬੜਾ ਬੰਦਾ ਦੁਬਈ ਆ ਸੀ ਇਹ ਤੇ ਰਾਹੁਲ ਗਿਆ ਹੀ ਤੇ ਮਾਈਕ ਲਾਉਣਾ ਕੀ ਰਹੀ ਤੇ ਮਾਈਕ ਲਾਉਣਾ ਨਾਲ ਕੀ ਉਹਨੇ ਬਣਾ स्ट्रीम का होता है देख रहे हो लाइव स्ट्रीम
हाँ बस
तो ये बोलो कि ब्लू स्क्रीन आ रही है यूट्यूब वाली तो वो लोगों को डाल देते हैं
अच्छा कन्वर्ट
तो दिक्कत है ना वो भी बात है तो वहाँ तो आके नहीं हाँ ठीक है तो
नाला हो मैंने तो बहुत कर लला यार बहुत ले जाने में बहुत ये तो ये है साल पहले लाई थी 4 साल जान दे हो बड़े पेट्रोल ये पहले भी लाया ये तो यार
कितने को जाना नंबर हो गया फॉर्म करने के लिए आएंगे इसका पता नहीं साल में तब तो फिर हम आईडी कार्ड साल में खत्म हो गया बहुत सारे हो गया
I request everyone to rise as our dignitaries are here. A very warm and heartiest good morning to one and all present here and connected virtually. A warm welcome is never complete without warm words. On behalf of Industrial and Production Engineering Department, Dr. B. R. Ambedkar National Institute of Technology, Jalandhar, Punjab, myself, Dr. Rajiv Verma, take immense pleasure, privilege, and honor in welcoming you all in the inaugural session of the 7th International Conference on Production and Industrial Engineering CPIE 2023. Great things happen when great minds gather. It is with the great anticipation that we welcome all of you to this congregation. Now I request the dignitaries to take the dais, please. We have among us Professor B.K. Kanojia, Director of the Institute, Professor U.S. Dixit, IIT Guwahati, Professor Sunil Pandey, Professor Reed from Johannesburg, Professor Bhardwaj, Professor Garg, Registrar Ajay Bansal, Head of the Department L.P. Singh, and Ajay Gupta. We extend our gratitude to all present since you have traveled long distances to here and nonetheless for those who are virtually attending. We really hope you are enjoying our hospitality and will have a productive deliberations. Our honorable dignitaries are seated, so we shall proceed with the tokens of honor. Well, it's time for the felicitations. To begin with, I would like to invite Professor Rajiv Kumar Garg and Professor Arvind Bhardwaj, the conference chairs, to kindly welcome our respected director, Professor Vinod Kumar Kanojia, with a token of appreciation. We all are indeed delighted and honored by your presence on this significant day. May I now invite respected director Professor Vinod Kumar Kanojia, Patron of C2023, to felicitate our honorable chief guest Mr. Akshay Sangwan. May I request for the director to felicitate our guest of honor Professor Robert Reed with a token of appreciation. Professor Reed is head of the School of Mechanical, Industrial and Aeronautical Engineering, University of Witwatersrand, Johannesburg. Robert Reed is an aeronautical engineer. He worked in the industry designing components, aircraft structure before taking a position in academia. His research focuses on measurement of residual stresses in composites and metallic structures. He is a fellow of Royal Aeronautical Society. May I now request for the director to present a token of appreciation to Professor Uday Shankar Dixit, Dr. Dikshit is professor at IIT Guwahati and an authority in the field of manufacturing research and academia. It is always a pleasure to have you on our show. Now I invite Professor Kanojia to honor Professor Sunil Pandey, formerly with IIT Delhi, with a token of appreciation. Professor Pandey was also former Vice Chancellor and Director at Slight Longoval, Sangrur, Punjab. It is our privilege to have you amongst us, sir. I invite Professor Bhardwaj to present a token of appreciation to Registrar Professor Ajay Bansal. Thank you all. Prayer is the most powerful tool mankind has. While light symbolizes knowledge and divinity, it not only dispels darkness but also illuminates our souls. I therefore invite all distinguished dignitaries on the dais for lighting the lamp before Ma Saraswati for inception of the conference. I request the faculty, deans of the department to kindly join the lamp lighting. We also have amongst us Mr. Sangwan, he is a director in ITL Punjab. Thank you, everyone. May I please invite our respected director, Professor Vinod Kumar Kanodia, Patron of CPIE 2023, to felicitate our Honorable Chief Guest, Mr. Akshay Sangwan, Director, International Petrol Limited, Hoshiarpur, Punjab, with a token of appreciation. Thank you, everyone. Moving ahead with the formal addresses, I take immense pleasure in inviting Dr. Arvind Bhardwaj, Conference Chair, to apprise about the conference CPI 2023.
A very good morning to you all. Honorable Chief Guest of the day, Mr. Akshay Sangwan, Executive Director, Navika Industries. Honorable Director of NIT Jalandhar, Professor B.K. Kanadi. Our guests of honor and keynote speakers, Professor Robert B. Professor U.S. Dixit, Professor Sunil Pandey, Registrar Dr. Ajay Bansal, other dignitaries on and off the dais, delegates, students, ladies and gentlemen. After the grand success of 6 international conferences since year 2007, CPIE 2023 is the 7th in its series and has attracted a very good response from the academicians and researchers across the world. More than 230 papers have been finally accepted for presentation after a thorough review process, having representation of papers contributed from countries such as USA, Canada, Australia, South Africa, Zimbabwe, Botswana, Saudi Arabia, Brazil, and Algeria. Around 27% of the participants are participating offline, whereas rest 73% are participating online. So far, we have been organizing this event every 3 years, but we are happy to announce that henceforth we'll be organizing this event every year. And the 8th CPI is proposed to be organized in December this year, that is 2023. We are very thankful to the director of our institute, Professor B.K. Kanadi, for extending a full-fledged support to us and encouraging all of us for organizing this conference. Whenever we approached him for any support, he always extended all the help for making this event a grand success. We are highly thankful to the chief guest of the day, Mr. Akshay Sangwan, Executive Director, Navika Industries, for having accepted our request for being chief guest for this event despite his very busy schedule. It is important to mention here that it was Navika Industries that supported the very first edition of CPIE that was held in the year 2007 by wholeheartedly sponsoring the event. We are also thankful to the keynote speakers for the conference, Professor Robert Reed, Head of School, Wits University, Professor U.S. Dixit, Professor in Department of Mechanical Engineering, IIT Guwahati, Professor Jalandhar, Professor of Mechanical and Manufacturing Engineering, USSW, Sydney, Australia, Professor Sunil Pandey, ex-Professor Mechanical Engineering, IIT Delhi, and presently working with LNM Jaipur, and Professor Pradeep Kumar, Professor in Mechanical and Industrial Engineering, IIT, for having accepted to share their knowledge and rich experiences with the participants. We are also thankful to the reviewers for sparing their invaluable time for giving their useful suggestions for improving the quality of paper. Our thanks are also due to the publishing partners for the conference for supporting us to bring out the special journal issues in the material today's proceedings by LGA. We are also adapted to the Springer nature for agreeing to bring out 4 different book volumes based upon the conference papers. The titles of the books are Recent Advances in Operations and Optimization, Advances in Materials and Additive Manufacturing, manufacturing and additive manufacturing, and optimization of production of industrial systems. Thank you, Sprinter Nature, for agreeing to this proposal. I am also highly thankful to the entire organizing team, especially the young team of CPIE, including Dr. Rakesh Sharma, Dr. Kapil Goyal, Dr. Rajiv Verma, Dr. Narendra, Dr. Abhiral Mishra, Dr. Varun Sharma, Dr. Gurraj, for effort put in for making this event successful. The staff members and research scholars of the department also put in the best efforts. Let us give a big hand and applause to the entire organizing team for this. The theme of the conference, Manufacturing and Operations for a Sustainable Environment, has been very aptly chosen, keeping in view the importance of sustainability at very central core of the manufacturing operations. The manufacturing industry in India has been a significant contributor to the country's economic growth and development. In the recent year, there have been several policy initiatives by the Government of India, such as Make in India program, Digital India, the National Manufacturing Policy, and the Production-Linked Incentive Schemes. The manufacturing industry in India is increasingly adopting technologies such as Internet of Things, artificial intelligence, and blockchain to improve efficiency and productivity. However, there are several challenges as well, including inadequate infrastructure, high logistic costs, and shortage of skilled manpower. I am sure that the deliberations during this conference are going to address and propose solutions to meet these challenges. With these words, I wish all the participants a very wonderful and exciting time during the conference. Thank you.
Thank you, sir, for your valuable information. Proceeding further, I request Professor Rajiv Kumar Garg, the conference chair, to say a few words on this occasion.
Ladies and gentlemen, a very good morning to all of you. Honorable Director of the Institute, Professor B.K. Kanodia, the Chief Guest, Mr. Akshay Sangwan, that is Executive Director of Sonalika Techniques, Professor U.S. Dixit from IIT Guwahati, Professor Sunil Pandey from L.N. Mittal Institute of Information Technology and former Professor, IIT Delhi, Professor Robert Reed from Wits University, South Africa, Professor Bharadwaj, Professor Sachdeva, Professor Vishal Sharma, Registrar Dr. Ajay Mansal, Head of the Department, Dr. LPCM, my colleagues, PhD scholars, and dear participants from India and abroad. This is the real big day in the history of NIT Jalandhar. CPIE started as a sapling in the year 2007, has transformed into a big banyan tree. This is the 7th international conference under the banner of CPIE, starting from the first one, that is CPIE 2007. After every almost 3 years frequency we have been meeting, and this is the 7th in the series. Already told by Professor Bharadwaj, there was a big response. I am happy to share that more than 200 papers will be presented by the delegates during the next 3 days. I would like to put on the record the efforts put forward by the team CPIE 2023 by holding this mega conference and to provide a wonderful platform to the delegates from academia and industry for the fruitful deliberations and discussions. The theme of the conference is Manufacturing and Operations for Sustainable Environment. As we all are aware, the technology is changing very rapidly, and each day we witness new products and innovative way of accomplishing the traditional tasks. There are more expectations from the engineers to be innovative to meet the demand of the industry. According to a report of Forbes, manufacturing process as on date use roughly 1/3 of the world's energy. Even in lower intensity sector, that is those outside of the top users' world energy, manufacturing process as on date use roughly 1/3 of the world's energy. Even in lower intensity sector, those outside of the top users, such as chemical, refining and paper, energy often represents a significant cost, and that only stands to rise as global energy prices increase. By building sustainable practices into the processes, manufacturers can tackle their single largest sustainable obstacle while at the same time working to minimize environmental impact and conserve resources. Through the use of digital technology, manufacturers may already have a head start in their sustainability journey. In recent years, the implementation of lean processes using digital capabilities have boosted productivity, created safer workplaces, and reduced costs. But this automation through digital technology can also provide manufacturers is greater visibility into their production processes, equipment wear and tear, and more importantly, energy usage. Armed with this data, organization can then optimize production and improve predictive maintenance to diminish energy loads as well as reduce material and water waste, all key factors in building sustainability. But that may not be enough. Building a more sustainable factory floor should also mean greater use of renewable energy, now increasing competitive in terms of cost. There are a few ways to do this. Many manufacturers are taking advantage of power purchasing agreements, which can lock in fixed prices for a supply of renewable energy, sometimes for as long as 15 or 20 years. In other instances, manufacturers with large campuses are even investing in on-site generation using solar panels, wind turbines, and geothermal pumps to power their facilities. By reducing waste and water usage, adjusting energy loads, and tapping into renewable energy resources, the factories of future have the potential to drive measurable sustainability outcomes as well as reduced costs. There are steps manufacturers can take within their organizations and on the factory floors to make the shift towards sustainable more accessible, operating within the traditional framework of change management. It includes plan, execute, and reflect. Plan means as a first step, it's important to measure your facilities' current carbon profile to build a baseline of your environment footprint. This can inform your strategy and enable you to set clear targets and priorities. For execute, to carry out sustainability initiatives, new roles such as a chief sustainability officers may need to be developed in the organizations. In turn, these leaders can help determine which sustainability matrices the company is under pressure to deliver on and prioritize the investment as well as build any new capability needed. And the manufacturer can do more than simply measure the progress of their sustainability initiatives. They can also use the progress to create a clear market narrative around the positive impact they are driving and paint a powerful picture for investors and consumers, like all the while improving transparency. Ultimately, sustainable manufacturing can also be achieved by setting the right tone from the top, giving buy-in and considering all the change management implications. In this phase of ever-changing product and process technology, the responsibility of academic institutions can never be underrated, as we are the backbone of this circular task, where the curriculum has to be updated hand in hand with the rapid evolution of technology. The industry has to be duly supported and strengthened by the academic institution to providing them readily employable technical manpower and collaborating with the industry to upgrade their traditional system with a cutting-edge technology. With this word, once again, I am thankful to Director, Registrar, other administrative heads to allow us to organize this event. I am hopeful that during the next 3 days, all the participants will be getting exchange of ideas and resulting networking between them that will be beneficial for all of us. I am thankful to all once again and wish the great success for the event. Thank you.
Thank you, sir, for your words. Now I request Dr. Lakwinder Palsing, Head of the Department, Industrial and Production Engineering and Organizing Secretary of CPIE 2023, to express our gratitude to our facilitators.
Very good morning to all. Honorable Director, Professor B.K. Kanodia, Director, NIT Jalandhar, Mr. Akshay Sangwan, the Chief Guest of this event, International Conference on
Production and Industrial Engineering, Professor Reed from West University, South Korea, Professor Uday Dikshitri, Professor Pandey sir, all HODs, deans, and last but not least, my dear participants, friends, I welcome you all for this international conference at NIT Jalandhar. Much more has already been said about the conference. I would like to just mention a few things about the department. We have some strengths that I must highlight. That first of all, we have some very dynamic faculty members in our department, and they are ready to accept any kind of challenge, especially from industrial environment. So we have a big team of our PhD scholars, those who are dedicated to various research areas, including human factors engineering, whether the seat design, whole body vibration, in tractor seat design, or it could be composite, development of composite, and additive manufacturing, machine learning, and advanced machining, various areas, supply chain, change management. Not many areas are there. So it will be injustice if I will not recognize the support ever given by the Sonalika to our department for organizing the first international conference, and that was big chunk of financial support for us, and that gave us a lot of strength and confidence to go ahead, because events are that need some investment money expenditures out there. So I would like to go beyond this, not to have just sponsorship and all, because now NIT Jalandhar has grown up, it is flourishing and like anything, and we don't have competition with others, we have competition with ourselves. So I request on behalf of the department as well as the whole team of organizing of this event, that we present ourselves to solve any kind of problem regarding, it could be any design problem or in your unit. So we can have collaborations for consultancy and research work, and rather if you would like to establish any kind of lab in our department, we will be very happy and we'll appreciate and we'll welcome you with the wholehearted approach. So recently we have received a couple of projects which amount rupees 1 crores. I think we should give big round of applause to faculty members, namely Dr. Narendra, Dr. Mishra, Abhiram Mishra ji, Dr. Vishal Sharma ji, and many more proposals have already been submitted by the department, and I'm sure that some of them will be through and will have much more funding from different agencies. So now with this funding of 1 crore of rupees, we are eligible for submitting phased proposals, because that was a condition that one department should have. So that means I am just mentioning these things that from the journey, from the very day in 2007 when we started the first this conference of this series, and where now we have come up and we are grown now. We can address any kind of industrial problem, and it will be I think more practical and rather realization would be there if we have real collaboration and engage our students, whether BTech, MTech or
Limited. He is responsible for major thrust areas for the Sonalika Group. His key focus areas are advancing the existing businesses of the group and developing new sectors of opportunities. Mr. Akshay is mechanical engineer and masters in business administration. Sonalika Group is working toward becoming a global leader and exporter of tractors to over 120 countries. They have put up the largest tractor assembly plant in Ushanpur with a capacity to assemble 3 lakh tractors per annum. Without further ado, I take immense pleasure in inviting our guest of honor to share his experiences with our audience.
Morning. It is indeed a pleasure to share the dais with all the eminent academicians and talk with students and scholars from the institute. When I got this invite through Sarabjit, I was quite thrilled because this is one area which is of my interest. I have studied this, and for the past 15 years I have been working in an industry which totally depends on it. So indeed, it was something which synergized with my thought process and my interest, and I decided to be there with you. When I saw the list of papers which will be presented or shortlisted, I went through the whole brochure, and I could really relate to the topics which will be discussed over here in the next 2 days, because each and every topic is something which we are also working on. So if I talk about my industry, I'm from the tractor business, and as so kindly mentioned, that we have the largest plant for manufacturing tractors in India, and we are putting up another facility to manufacture another 1 lakh tractors shortly. What we are also putting up is another capacity to produce 7,000 tons of castings in Ushanpur itself. And the reason why we are doing this is we are seeing immense potential going ahead in manufacturing business in India. The tractor plant is being put up based on our export business, which has been growing tremendously. We are the largest exporters of tractors from India, and as mentioned that we are currently present in over 120 countries. We have assembly plants in 5 of them. Still, the demand is growing, so we have to put up an additional capacity. Castings, we decided because though India has a large base of casting manufacturers, the Western world is looking at sourcing castings from India. And currently, they are gobbling up all those capacities which are currently available in India. And we decided that to safeguard our manufacturing interests, we need to have our own captive industry. Now coming back to the discussions which I saw, the papers will be presented, they are quite relevant, and they are quite relevant right now as the industry is growing and metamorphing into something which is capable of addressing the global needs. One of the papers which I saw was on theory of constraints. It is something which we have adopted in our organization. Last 3 to 4 years, we have seen tremendous turmoil in the supply chain segment, and to cater to that, we adopted this theory. We have a software by the name of vector organization which works on the concept of theory of constraints. It forces us to produce what is required, not what we have the raw material for. And these are further getting enhanced. All those topics we are working on from concept stage, taking them into practical implementation. Then we are developing SOPs around it. We are creating boundary conditions to make sure that whatever concept which we have, they work properly. Then we are developing softwares to monitor whatever we have planned is happening as per our boundary conditions or not. We have softwares which communicate internally and externally with the parties to design or to course correct ourselves. So there is an amalgamation of mechanical engineering and software engineering which is happening in the industry right now. And it is largely being driven by the mechanical engineers in our organization. So this is one area of tractor manufacturing which I talked about. But right now, a lot of things are happening in India. India is opening up in a very different way. Especially the China Plus One policy has been a very big opportunity which has been promoted. And we see a lot of opportunities coming our way. There are new segments, new industries which are coming up. Space technology, aerospace technology, chip manufacturing, solar panel manufacturing. These are some of the areas which will require a very high level of understanding of manufacturing. And we would require a very high understanding of the technology as well. Even if we don't go that far, within our organization, we are seeing there are constraints in technology like what we really need to upgrade. Just to give you another example, one of our equity partners in the company is a Japanese tractor manufacturer by the name of Jalandhar. They recently put up an engine manufacturing setup in Chennai, and for that they wanted to localize their blocks in India. They traded with one of the best casting companies in India, but unfortunately that company also was not able to deliver the requirements because the casting wasn't great, the quality were very good. And they had difficulty maintaining quality levels because of rejections which were not thought of. So we realize that if we have to go local, our technology adoption has to happen. And this is something which we are seeing in basic automotive industry as well. And I'm sure that the scholars, the students who are working on these papers will find solutions to these. As suggested by sir, I would invite those who are working on these new papers on the technologies to come visit us, see how we are working on these technologies, get suggestions, learn from us, and improve upon these things because we are at the cusp of understanding the whole concept of what the globe has already achieved. We would also like to invite students who would like to have projects with us, on various areas. Now, if I talk about internal combustion engine, currently there is a big debate going on, and I'm sure everyone is interested in knowing what is happening. Will it be electrical? Will it be hydrogenized? Will it be CNG? Which way will it be going? And to be honest, there is no right or wrong answer. There might be that all these technologies will work together. So we have to be prepared on all the fronts right now. If these are areas of your interest, we would invite you to come have a look at what we are doing, give us suggestions, be interested, work with us on these things. Because there is no way that the traditional program is going to work. We will be adopting better and higher end technologies to compete in the global market. Needless to say, as I said, that India is having a great opportunity. There are heavy investments which are happening within India. As was shared a couple of weeks back, last year out of 195 countries in the world, 160 invested into India. So you can be rest assured, those students who are graduating right now, you will be stepping into a world open of opportunities if you're working within India. And for the coming few decades, at least, this will grow at a very, very rapid pace. So this is an opportunity for you to grab, and you should grab it with focus. Startup culture is growing like anything, and I'm sure many of you would be looking at it as an area of interest. And this is something which we also encourage, because that is the area where new innovations are tested, new technologies are tested, and new concepts are brought into the ecosystem of manufacturing. So all in all, I would wish you all the very best. I would urge you to explore, to go out more. The industry is very open. You can interact with us. You can come to us. We will be very happy to have you on board. Understand what we have learned so far, build upon it, and then deliver something. So thank you so much. All the best.
Thank you, sir, for spending your valuable time with us. We are happy to have with us our worthy director, Professor Vinod Kumar Kanodia, who has consistently been the pillar of strength and source of motivation for all of us at NIT Jalandhar. Let us hear it from the horse's mouth itself. Welcome.
Good morning to ladies and gentlemen. Mr. Akshay Sangwan, Executive Director, Sonalika Tractor, Hoshiarpur. Professor U.S. Dikshit, IIT, Guwahati. Professor Sunil Pandey, L.N. Mittal Institute of Information Technology and former Professor, IIT, Delhi. Professor Robert Wright, WIT, University of South Africa. Conference Chair Professor R.K. Garg, Professor Bhardwaj, Organizing Secretary Professor Anis, Professor Vishal, and our Registrar Professor Ajay Bansal, and Head of Department and Dean and our colleague and dear participants. तो मैं प्रोफेसर को मिस्टर अक्षय सांगवान जी का बड़ा इत्मीनान से सुन रहा था, तो आज सही मौका है कि मैं चाहता हूं कि जो सोनालिका ट्रैक्टर की वजह से हमारा एनआईटी भी जाना जाए और एनआईटी की वजह से सोनालिका जाना जाए, तो इस वजह से अगर कुछ ऐसा पॉसिबल हो कि हमें कुछ आप ऐसा कर सके जिसकी वजह से हमारे स्टूडेंट हमेशा आपको याद रखें, तो वो पॉसिबिलिटी हो, तो आप देखिए किस तरह से हम लोग आगे बढ़ सकते हैं और सोनालिका को हमारे जो एनआईटी जालंधर में एडमिशन लेने वाले स्टूडेंट है वो हमेशा याद रखें कि सोनालिका भी यहाँ पे होशियारपुर में एक फैक्ट्री है और इतना अच्छा काम हो। So first of all, my heartiest congratulations to organizing team for holding this mega conference. I am happy to share that NIT Jalandhar has been serving the nation very actively through providing quality of education which has not been hampered even in tough time of COVID-19. This is a seventh conference being organized by a team of a Department of Industrial and Production Engineering that show the commitment and capability of the department. So dear delegates, I am sure that many people out of you will be visiting NIT Jalandhar for a first time, and I would like to share some of the newest achievements of the institute. During 2023, NIT Jalandhar has been placed at an NIRF ranking 52, which is achievement in itself. All older institutes, including IITs, ISC Bangalore, NIT, Central University, and private university, participate in NIRF framework and getting the higher ranking. So the commitment of the faculty, staff, and institute of the institute. As on date, the institute offering 11 BTech program, 17 MTech program, 3 MSc, MBA and PhD in all streams. I feel proud to share that from this academic year, NIT Jalandhar will be starting new BTech program in a VLSI and data science, 3 new MTech program in data science, data analytics and electrical vehicle design. Hence, taking a lead amongst all CFTI, NITs and IITs. Further, NIT Jalandhar is one of a limited institute allowed to start 4-year integrated BSc and B.Ed program in the light of a NEP 2020 by the Ministry of Education. NIT Jalandhar is the first institute amongst all NITs to start off a 5-year integrated BTech and MBA program in collaboration with IIM Amritsar, providing the new opportunity for its BTech students. Under its flagship, NIT Jalandhar has achieved another milestone to start online MTech program in power system and reliability, tailor-made program for a working executive of the Power Grid Corporation of India Limited. During the last 1 year, 21 new patents have been filed by the faculty and students of NIT Jalandhar. The institute had 2 incubation centers where the faculty and students have registered their startups institute had strong alumni network with a more than 10,000 pass out students registered under it. In the era of a globalization, international competitions and scarcity of a resources both for industry and university, collaborations are required that will help pooling, sharing and optimizing the use of availability of resources. Academic institutions and industry are required to work hand in hand. For this, various modes will be benefited like the establishment of a industry institution partnership interaction cell for which NIT Jalandhar is moving very fast. Organizing workshops, conference and symposia with the joint participation of the faculty and industry. The participation of an expert from an industry in a curriculum development and teaching. Joint research program and field study by faculty and people from an industry. The memorandum of understanding between an institution and industry to bring the two sides emotionally and strategic closer. The collaborative degree program to meet the requirement of an industry. R&D program is sponsored by industry at the institute. Scholarship and fellowship institute by the industry at the institute for the student, etc. So I am sure that NIT Jalandhar would continue to strive for establishing a close linkage with the industry in Punjab and India. I am optimistic that during the next 3 days, all the participants will be getting exchange of an idea on this platform, and resulting networking between them will be benefited for overall growth. I have no reservation to say Department of Industrial and Production Engineering of NIT Jalandhar is putting unparalleled effort for academic excellence, research, consultancy, and alliance with a local industry. I assure wholehearted support for a department and institution activities in continuous basis. Once again, I appreciate the effort of the organizing team of a conference of a production in industrial engineering and wish them best of luck for its success. Jai Hind, Jai Bharat.
Thank you, sir, for your encouraging remarks. Moving ahead, I request our director, Professor Kanogia, and other guests of honor, Professor read all the dignitaries to launch the abstract booklet and formally declare the conference open. I invite all the faculty of the Department of IP to join the book proceedings.
Yes, so please talk about it. What was the last one? Yes, Ahmed? Yes.
conclude the ceremony, I once again thank everyone on the dais, colleagues, students, volunteers, and all the delegates for making the conference success. And now I request all the dignitaries and delegates to rise for the national anthem.
विनायक जय हे नारक भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
With this, we conclude with the inaugural session of the conference. And before we proceed further toward the keynote speeches and to the technical sessions later, let us first assemble for a group photograph outside the IT building, followed by IT at the back foyer. And immediately after the PE, we shall be meeting here only for our first keynote speech by Professor Lee. Thank you, everyone.
में लग रहे फोटोग्राफ हो रहा है बस उसके बाद हेलो हेलो हाँ जी बस बढ़िया मैं इधर ऑफिस वो यार पैच कॉर्ड है ना अपनी वो चूहे निकलती है जो उधर स्विच खोलोगे ना जो सबसे पहले नीली जता रहा है वो पतली वाली वो है वो पैनी यार कोई 1800 2000 दी हाँ कौन बोल रहे हैं बल्लू सिर बल्लू तो बड़ा था 700 700 दी कोई नहीं है यार वो 12 16 1800 2000 की केबल है वो पर एक मिनट है
कॉपी कर लो
Sir, which one is this? There are 4 5 5 next.
I copied lots of things on US. It's the one B2.
B2.
Copy. Onto your hard drive.
Yes.
Because there's videos. Sometimes it costs you to stick in the right. It doesn't really cost.
Do we need to remove this chair?
Oh, no, that's fine. No, I just.
I didn't know you all empty. All right. That's what we did.
Otherwise,
Sir, it is working fine.
Except for the big fashion, we just.
Yes, sir, you can check.
so just,
Yes, sir, that's it.
I will be saying that.
Slightly
Maybe we test carry load.
अच्छा ठीक है।
अच्छा ये एग्जैक्ट और ये साउंड and you have a remote control as well. In case you want to change this light, you can just
शायद किसी ने उठा लिया। नहीं आया तो कुछ चालू कर दे।
This is the main one.
this was a point where
This one. Red one.
red one. Couple of slides for you to get used to. Okay, sir. Thank you very much, sir. The weight is better.
So please get your flashlight.
Back up. Back up. Right, and it's on. Remember that. That's the landscape.
कोई आता कोई काम नहीं कर रही क्या करूँ? हाँ।
सुना के करना ही है।
detrimental effect of residual stresses in his early career. He has spent his time in academia focusing on the measurement of residual stresses, primarily on composite structures. Since 2014, he has been head of the School of Mechanical, Industrial and Aeronautical Engineering at the University of Witwatersrand in Johannesburg, South Africa. He is currently the co-chair of Alicanto, the International Association of Aviation and Aerospace Education, which counts many prestigious and high-profile institutions among its members. We are immensely grateful to Professor Lee for coming over and spending his valuable time with us. Today, Professor Lee will be presenting on residual stress management in composite materials. Over to you, Professor Lee.
Thank you for the introduction. Before I continue, I'm just going to say thank you to inviting me here, and I'd like to say thank you to the organising committee and in particular to Vlog for inviting me here today. It is indeed a great honour, and I have never been to India before, so this is the first time I've been here, and it's a wonderful experience, and I've been looking forward to it for a long time. Some people might not realise that South Africa and India had a very long common history, and I've always wanted to visit India, and 2 years ago I lived in a house in Johannesburg, and people might forget that the great Mahatma Gandhi actually lived in South Africa for a long time and lived in Johannesburg for a while. And when at one stage I lived in a house that was only about 400 meters away from the house that he lived in. It's a wonderful thing. Now, I'm going to very briefly talk to you about my university and my school, and the main reason for that is so that we have the opportunity, hopefully, for common work and collaboration. We have the opportunity for common work and collaboration. Then I'm going to give a brief introduction to residual stress measurement. And the reason I'm going to be talking about residual stress measurement is, since this is a conference on production engineering, residual stresses, by definition, largely arise because of different production processes, which means that they generally have detrimental effects, and it's important to be able to know what they are. Then I'm going to give us a little bit of history or an overview of the work that we've been doing at our university. Obviously, residual stress measurement is a very big field. I'm going to be talking about that part of the field that I know about. That's why I'm limiting it just to our work. And then a small introduction to future work. Now, the name of the university that I come from is the University of the Witwatersrand. An interesting fact, Johannesburg is the largest city in the world that was sited without any concern about where water is. Johannesburg was sited where there was gold, and gold happens to be found in a ridge that runs across South Africa for a short distance, and in the English translation would be Whitewater Ridge, but in the Afrikaans language it's pronounced as Witwatersrand, and this is the University of the Witwatersrand. That ridge is actually the continental divide, so some buildings on our university campus with rainlands on it, the water flows into the Indian Ocean, and other buildings, the water flows into the Atlantic Ocean. My university is home to 4 Nobel Prize winners. We're, of course, very, very proud of them. And if our university was situated in other parts of the world, it would be probably more well known. Unfortunately, the fact that we're based in Africa tends to mean people tend to think that our university is not as substantial as it actually is. We've got 41,000 students split across 7 faculties. A bit more than half of our students are female. About 40% of the students are registered for postgraduate studies. And I guess it might be similar to India. Roughly more than half, actually, of our students are students who are the first students in their family ever to study at a university. We're located in Johannesburg, which is the economic hub of the African continent. And My particular school was a founding school of the university. So this is a photograph of the university when it was founded in 1922. There is a little dot over there, which is indicating that number one is one of the buildings that we are based in. Over there, and move on 100 years, they look like this and like that. And we've got around about 30 full-time academic staff, around about 25 part-time academic staff, and the technical staff, and more than, actually now, it's the start of the academic year, students are still enrolling more than 1,100 undergraduate students, and a bit more than 400 postgraduate students. So, I'm going to very briefly talk to you about some of the work done in my school that's not related, it's not my field of expertise, but it relates to colleagues' work in production engineering, and I'm presenting this with the hope that this work will be interesting to some of you and we can potentially have collaboration between my university and your university. So the first is in the area of friction stir welding. And we've got good facilities here in terms of the welding technique and also in terms of scanning the welds for any possible flaws. Of course, while friction stir welding has many advantages over other welding techniques in terms of reduced heat affected zone and also residual stresses, it's not impervious to that. So on laser shock cleaning with the intention of introducing beneficial residual stresses very deep into the structure. And as an illustration, this is how it actually works. There's a water layer running over the surface which helps to provide inertial confinement to the ablation shock provided by the laser. And each laser pulse actually provides two separate shocks going quite to provide very compressive stresses into the surface of the material. We also do, obviously, like many people do, a lot of work on additive manufacturing, but again, laser shock cleaning can be used to provide beneficial residual stresses and also to improve the surface texture of something that's been done through additive manufacturing. We also have, we work with our colleagues in the metallurgy department in producing innovative cutters using new materials and so on. But one of the things that we found is that by using laser shock cleaning, we can improve after a certain length of cut, we can improve the surface of the cutter from that sort of surface to that sort of surface. So by introducing significant residual stresses into the cutter, we can improve the life expectancy of the cutter. This work here in terms of cold spray is, I'm not sure how many people are familiar with cold spray, but rather than using heat to melt material onto a surface, you can use kinetic energy to achieve the same effect. This reduces residual stresses and ends up with providing a superior surface coating. We can use it for repairs of aircraft components. What is shown here is actually the work being done in terms of metallization of the plastics and composites for the purposes of antimicrobial coatings. And we found that by the appropriate combination of metals, you can ladder creating surfaces that kill harmful bacteria in hospitals almost immediately. Right, I'm now going to continue on to the area that is my personal passion, and that's the area of residual stress measurement. So, when we are working with residual stresses, before we can measure anything, we need to have a reference stress. If you are going to do a tensile test on some form of coupon in a lab, you know that you start off at zero stress and then you apply a load and you can then reference the stress to that zero stress. When you're working with residual stresses, it's not as simple as that because you've got stresses that are already built into the structure as a consequence of the manufacturing process, And we somehow have to find a zero reference stress so that we can compare our stresses to that reference stress. Now, there are different ways of doing it. We can use diffraction techniques or relaxation techniques. When working with composite materials, because, and I'm working primarily with fiber reinforced plastics, because those materials are not crystalline in any way, we can't use X-ray diffraction or neutron diffraction, and the end result is we're forced to use relaxation techniques. And what do I mean by relaxation technique? What you end up doing is you remove material from the structure in one way or another. And by removing the material, at the edge of the cut material, you force the residual stress at that location to be zero. And in the process of doing that, that changes the stress field around the area where the material has been removed. And depending on the nature of the residual stress field, the response that you get will differ depending on the residual stresses. Now the problem is you are removing material in one place and measuring strain at another place. And that makes things a little bit more complicated, which means that you end up getting an inverse, it's called an inverse problem, which means, which certainly introduces complexities at a later stage, and I'll talk about that a little bit further on. The two, of course, you get residual stresses at a variety of scales, but I'm going to be talking primarily about stresses at the microscale and the mesoscale. So, in terms of microscale, what is the most obvious situation that you can think of with composites? And that is a situation where you've just got the unidirectional laminate. So you've got, for argument's sake, glass fiber surrounded by a polymer matrix. When the polymer matrix cures, it tries to shrink, especially if you've cured it at elevated temperature. The coefficient of thermal expansion of the polymer is higher than that of the fibers, and as a consequence, the fiber tries to shrink, the matrix tries to shrink. The fibers prevent that, and you land up with a situation where your fibers are loaded in compression and your matrix is loaded in tension in the fiber direction, but as a whole, the laminate is at zero stress. And this presents difficulties in terms of how you measure what those stresses actually are. Because if you remove material, whatever hole you make or however you do it, the scale of your removal is going to be far bigger than the scale of the actual fibers themselves. And that means that you will still also measure zero residual stress. So the way in which we were able to do this is by recognizing that when you heat the polymer, the elastic properties of the polymer reduce through 2 orders of magnitude, and consequently you effectively are able to remove the stresses from the material at high temperatures, which means then that if you use different unidirectional materials and you heat them up to about the Gauss transition temperature of the polymer, what happens is you release the stresses, and as a consequence you're able to find the locus of zero stresses, and you can then work out what the residual stress distribution in the laminate was before you started. And obviously this is a function of temperature as well. Now, we were actually the first people in the world to be able to work out how to actually measure residual stresses in unidirectional laminates. At the mesoscale, you can get residual stresses arising from differences in properties of pliers from one part to the next. Even if you're using the same material, if you align them in different orientations, you will get different residual stress distributions through the thickness of the laminate. And also you can get residual stresses arising from curvature. To start off with, I'm going to just talk briefly about residual stresses arising from curvature. And of course, in terms of the tails, you're going to get mesoscale residual stresses arising from a range of different surface treatments. So, talking about curvature, we find that pipes, very, very common industrial application, can develop very significant residual stresses. And the reason for that is that the circular configuration prevents the amelioration or reduction of residual stresses through bending. Now, strangely enough,
there are some very serious flaws in the design codes for pipes. Residual stresses are never considered in the industrial codes for pipe manufacture, and people just assume that we need to keep the mechanical strains in the structure low, and the result of that is the codes tend to land up with very thick pipes. The problem is that very thick pipes introduce large residual stresses in their own right, and those residual stresses are never actually counted in the design. So please be wary of looking at it. People will always require pipes to be built to some code, but please be aware that those codes have some significant flaws in them. And to illustrate this, see how residual stresses develop. In the case of a pipe, typically the pipe would be made through a filament winding process, so the fibers would be aligned in the circumferential and axial direction, but there would be no fibers aligned in the through thickness direction. What this means then is that the axial and circumferential stiffnesses are reasonably low, but there are no fibers through this in the radial direction, and as a consequence, when the resin system or the polymer matrix tries to cure, shrinkage happens, but there's nothing to prevent that shrinkage, and what happens is that the pipe tends to move towards the center line, and as a consequence of that, we get compressor stresses in plane on the outer surface and tensile stresses on the inner surface, which is bad from a stress corrosion point of view because that's typically where you've got your aggressive chemicals. So, and then of course you'll end up with radial tensile stresses in the through thickness direction. And the thicker the pipe, the worse these stresses actually are. To illustrate here, this is a cross section through a pipe that's got quite a thick wall, and you can see these white lines running around the surface there. Those are illustrations of where we've had delamination failure. Simply once we remove the pipe from the mantle, the pipe fails itself automatically. If we go to a pipe that's slightly thinner wall, although this has still got a small amount of failure, you can see a bit of a white line there. The end result is the stresses are reduced. And if you go even thinner, we end up with a situation where we do not have failure immediately after manufacture. So we developed a method for measuring the residual stresses in pipes, and it's based on a method that was originally developed about 100 years ago for isotropic pipes. But we now have to take account of the fact that we've got completely anisotropic properties in a composite pipe. And what we do is we end up removing material from the outer surface through the process of grinding. But we have to remove the material very, very carefully to make sure that we do not introduce any form of significant heating in the process. So in this case, we ended up removing 0.03 millimeters on the diameter per cut to be able to eliminate the heat as far as possible. The maximum temperature here was 37 degrees Celsius. If you do that, you can measure strains on the inner surface of the pipe, and from that you can come back and calculate the residual stress distribution through the thickness of the pipe. Noticing that again the stresses in the radial direction are comparatively small, but as a feature of composite engineering design, those stresses seem to be absolutely insignificant, but we must remember that the through thickness strength of composite materials is also insignificant. So stresses like that, and not quite at that level, but you go a little bit higher than that, and you can have through thickness radial failures. So what's interesting about the SATS method is that we only remove material in two planes by simply skinning material off the surface, and yet we are able to find all 6 residual stress components directly. Again, we were the first to be able to do this in terms of measuring the residual stresses properly in fully anisotropic pipes, and the method's an exact elastic solution, so that makes it very computationally efficient. Now, what's perhaps of more interest in industrial applications for aerospace situations is measuring residual stresses in flat plates. And that can be done by a variety of ways. We can remove a layer of the surface and see the response of the structure to the removal of that layer. Or we can cut a slit in the surface, or what's very commonly done, certainly in metallic materials, is incremental hole drilling. And in incremental hole drilling, what you do is you go and you remove the material progressively by making a hole deeper and deeper and deeper, and measuring the response of the structure to the removal of that material. So in this particular case, you put strain gauges on the material, and you would initially measure zero residuals, or zero stress or zero strain. You know the stresses that are built in, but you would have a zero datum, and then as you start to remove material from the hole, what you will find is that the strain response measured progressively changes. And the trick is to work out what strain distribution as a function of depth corresponds back to what stress distribution through the thickness. And we can do that by a number of ways. So the first method is known as the integral method, which is very widely used in metals. And then the second method is through series expansion. Now I'm going to start off about series expansion. It was first proposed in 1981, but the technology at the time didn't allow it to actually be used, and it was considered to be unstable. The approach that is followed is that you've got a laminate built up of a number of different plies, and we can assume that some form of temperature distribution is applied to the material. What we do then is we assign coefficients of thermal expansion to the different plies. So we say that most of the plies have got zero coefficient of thermal expansion, but some of the plies have a coefficient of thermal expansion of 1, and that then imposes what's called eigenstrain onto the structure, and as a consequence, we then get a stress distribution. Now, what we can do is for each and every eigenstrain distribution, we can work out what variation in measured strains we would get. And the trick then is to work back and say, for each eigenstrain distribution, we get this strain distribution. What combination of eigenstrain distributions will best match the what was measured experimentally? We found out by using this method and using modern techniques in terms of improved finite element models, improved experimental equipment, and much finer depth resolution, that it's entirely possible to get good results from the method, and low instability exists. And in fact, it can also be applied it can also be applied to metals. But what's important in terms of composites is it's fully coupled, so it can be applied to any fully anisotropic element. And the importance of this is that by having this alternative method, we get on this situation where we can validate results using one method or another method. Now, just to get an illustration of how this works, what we see here is some measurements, say, for strain gauges aligned in the X direction. And what happens then is we can assume that each ply has got some combination of order. So if we were working to a fifth order, we would say that the stress distribution in each ply, the eigenstrain distribution within each ply, can be represented by, say, a fifth order polynomial. As we increase the order within each layer, we are better able to describe the measured strains, and consequently, while we have improved resolution in terms of the strains, for each particular order, we then get a different stress distribution. And one of the things that we have to be careful of, though, is that as we go to higher and higher order stress distributions, we are better able to approximate the measured strains, but we have to appreciate that the measured strains have actually got some experimental uncertainty. And if we go too high, we actually start to fit the noise rather than the underlying strain distribution. So what you then have to do is make use of Monte Carlo. So for each series order that we consider, we have to introduce additional measurement uncertainty and see how the structure responds to that measurement uncertainty. So if should start off with the moment. So to start off with, for that particular strain distribution, we will get a line. And then if we introduce some noise to it, we will get additional lines. And we do this again and again and again. We've seen here trial 1, trial 2. Typically what we'll do is we'll do something like 10,000 trials. And for each trial, we'll measure a slightly different residual stress distribution. And as you can see, in some cases they can be significantly different from each other. But the advantage of doing it this way is that we are then able to get a fully a proper estimate of what the residual stress distribution is, and more importantly, what the uncertainty is. And you can see that there are regions where we have got now very where the lines tend to align with each other, and regions where they don't, and that then allows us to find the actual best fit to the experimental distribution, and also the uncertainty associated with that, which is great. And that tells us for each residual stress, possible combination of residual stress distributions, what the residual stress distribution would look like. But the issue is we still have to decide which combination of series orders we should be using, and in this particular case, what that means then is we first got to make sure that our solution converges to the measured strain, and also that we do not get into a situation where we have unstable situations. So in this particular case, we have to consider all possible combinations, and we can plot them over each other, and we can see where there is alignment and where there isn't alignment. And what we eventually do is we choose the combination of series orders that gives us the lowest absolute uncertainty, whilst we still have a convergence in the results. So in this particular case, it works out that the solution with the lowest uncertainty is about to appear. It's 2021, meaning that we're using the second order polynomial in the first layer, the zeroth order polynomial in the second layer, second and the third, and the first order polynomial in the fourth layer, and that then allows us to get an estimate of the residual stress distribution and the uncertainty through each individual layer. Another way of doing it is using the integral method, which is very widely used in metallic structures to the extent that there's actually an ASTM standard associated with doing it in metals. And in this particular case, we make use of what's also called the unit pulse method, where we incrementally increase the depth of the hole while applying constant stress at each additional increment as we go deeper. Now the point is that this method is very conceptually simple. The problem with it is that it can only be applied to quite thick materials or quite thick laminates, because in actual fact, as you can see, when we apply stress like that on the top surface, we're actually applying a bending moment to the laminate, and that bending moment distribution is not taken account of, and so the laminate is not entirely in equilibrium, which can introduce errors. And the way in which it works, and I'm not going to go through the maths here, but we find that it's not a least squares solution in terms of finding the best fit. It's an exact solution, which makes it very, very sensitive to experimental scatter. And it requires some form of regularization to reduce the scatter. Now, it turns out that the method of regularization, which is used in metals, can't be used in composites, because we're not able to separate the biaxial and shear stresses from each other, because we're working with composite materials, and the stresses and strains in the in-plane, so the direct stresses and the shear stresses are coupled to each other. We were able to develop a method of doing this for an approximate method for cross-ply laminates. And as an illustration of how this works, one of the features of the integral method is that if you use only a few steps, and that would be say the crosses over there, we note that if you have just a cross there and there, across there and over there, we get the uncertainty associated with each of those crosses is quite small, but the resolution is quite good. And as we try to improve the resolution by adding in more steps, we can now go to the green crosses, the green circles. As we add in these additional depths in terms of the experimental process, we end up getting better resolution, but at the expense of increasing uncertainty. And the argument's sake that in the worst case, if you went to 16 steps, that's what the red triangle, you'll see that although we've got much better resolution, the uncertainty associated with each point is very, very large to the extent that the results are actually not useful at all. By making use of the regularization approach that we were able to introduce, we now get the line indicated by the dotted line there, and we can then see that by regularizing the 16-step approach, we're able to get very good resolution and also have far reduced experimental scattering. If we compare the results obtained from the incremental hole drilling method with our method of regularization, and we compare that to the series expansion, which is fully coupled, so we know that it takes account of all possible interactions in terms of stresses and strain, we see that there's a very good correlation between the two methods, which is comforting to know that the approximate regularizations we use actually works. Now, one of the big issues is how deep can you measure residual stresses? And the answer to that is actually, it depends, but if you're using the incremental hole drilling technique, the depth that you can go to is not particularly deep. Because if you think about it, as you remove material recipe from a hole, the material the hole is quite deep. The material that you remove there has residual stresses, but when you remove those stresses by removing the material, the effect of that stress removal has to make its way back up to the surface where it's needed. So the deeper you go into the hole, the less you are able to measure or notice any form of experimental strain on the surface. So we did an investigation to see what happened here. In this particular case, we already know that we could go at least 0.4 millimeters deep. So the question was, how deep can we go beyond that? And if you have a look, what I'm showing you here is the red line is the results that we would get from a series solution, whereas the black lines are the results that you would get from the integral method. And we note that at this point, the two stress distributions are very, very similar to each other, but in the second part, they are sort of similar, but not particularly close, but in both cases, they match the experimental strains reasonably well. If we then go a little bit deeper, we still see that the stresses over here still match each other reasonably well. Things are not looking particularly good over there, but the strains are still matching nicely. If we go a bit further, what happens now is we start to see that there's a reasonable correlation at this point, but things start to move a little bit, there's a bit of discrepancy at this point. And what's happening now is that as far as the series solution is concerned, to start off with, there wasn't enough data over there to get any useful fit, but as we go deeper, that additional data starts to have an impact, and it then starts to improve the accuracy of the series solution. Go a bit deeper still, there's still reasonable correlation, and then if we go deeper again, what we notice that integral method starts
Camera stand by both
going crazy. The reason for that is that the integral method is better able to match the strains in this region. And if you've got any form of the experimental scatter down at greater depths, the effect of that experimental scatter then starts to have a significant impact on the final stress distribution. The important point to note here is that at this point, the depth is around about, by the time you get to about 1 millimeter in depth, you're not, the results can't be trusted. Obviously, this depends on the diameter of the hole that you use. In this particular case, we were working with a hole of around about 1.8 millimeters in diameter. If you had a bigger hole, you would then get, and you use strain gauges that were sort of scaled position accordingly, you would be able to go deeper. But the reality is that, in this particular case, if you go to a depth much beyond about half the diameter of the hole, your results start to become discernible. So we can see exactly the same thing when we consider the strains in the y direction. And I'm not going to go through it in detail. Effectively, the results follow the same trend as you will see for the stresses in the x direction. So, yes, we can only at the moment go about half the depth of the hole diameter, which actually aligns with the results that you would get from the ASTM standard for metallic structures. Unfortunately, there's people in the field who come up with new experimental strain measurements who will tell you that you can go 6 times the whole diameter and so on, but they're not actually taking account of the effects of experimental scatter on the final results when you do the inverse solution. And once you do that, what you find is that these results hold, that you can only go about half the depth of the whole diameter. We've got some ideas for how we can go deeper. The initial results are looking promising, but we still have to see what we can get. One of the things we've been looking at is the measurement of residual stresses in incremental hole drilling. Sorry, in additive manufacture. And obviously, if you're using selective layer melting, what you end up with is each layer melts or fuses onto the layer beneath it. So there is in effect a very narrow weld line between one layer to the next and the next and the next. Now the stresses at that interface are the same, but we don't, at a macro scale, but we don't know that the stress follows smooth distribution at a micro scale. So within each layer of material, you could have a stress distribution that varies and then steps onto the next layer and the next layer and the next layer. So at a large scale, there may well be a general trend in stress, but at a much finer resolution, you could find significant variation of stresses relative to that general trend. And this is something that we tried to see whether we could measure that. It required a little bit of modification to the analytical technique. And we went ahead, we made some specimens that were 3 millimeters thick, each layer only being 60 microns depth. And that required us then to, when using incremental hole drilling technique, to remove layers of very fine increments so that we would be able to get some form of stress distribution within each ply or each additional layer that was added on. And what you see here is the black lines of the interfaces between each of the individual layers that were added on in the additive manufacturing process. And we were hoping to see some form of stress variation within each layer. What we found, however, was that we are finding some form of repetitive pattern, but that pattern extends across 5 or so layers of the additive manufactured material. At the moment, we can't explain why this is the case, and before we try and publish it or do anything more significant with it, we believe we need to repeat the experiment with different materials or something so that we can work out, is this an experimental anomaly, or is this real? Because at the moment we can't quite explain what is going on there. And if anybody would like to partner with us on that, we would be very happy to work with you in that regard. This is obviously just the stresses in the perpendicular direction. So we now move on to we looked at what we've been doing. Where will we be going? Well, we're going to be looking at trying to measure stresses at greater depths. Obviously, there's always scope to improve the analytical techniques, so that means that we can reduce the experimental uncertainty or introduce better ways of interpreting the experimental results. There's always the option of changing the experimental approach, and we're working on some exciting ideas in that regard. Obviously, there is also the issue of measuring residual stresses in new materials or in new engineering contexts. And again, if anybody would like to collaborate with us in any of these areas, we would welcome the opportunity for collaboration. Now, I was asked to please try to keep my presentation as short as possible. I hope I haven't outstayed my welcome, but thank you very much for your time, and if you've got any questions, I'd welcome the opportunity to engage you.
Yes, the house is open for discussions. If queries you may ask, turning on your mics.
Of course, if anybody's having interesting problems associated with things that are going weird in the production process that could be related to residual stresses, please let me know.
Yeah, very good presentation, okay, about this one. So I guess that you are aiming to make the surface residual stress compressive or that type of, that is the aim, because residual stress is always in combination. If you work inside, then you will be somewhere compressive, okay. So yeah, so it is the location which is important, where you get more. Yeah.
Well, ideally you want to compress the stress on the surface, because that's where it really matters. And it doesn't matter whether that's from a fatigue point of view or a stress corrosion point of view. That's what you would like. But if, for instance, in the situation where you're dealing with a pipe, the physics of the problem boil down to the fact that the polymer matrix shrinks and introduces tensile stresses on the inner surface. And until we can come up with a polymer that actually, for argument's sake, expands while it cures, we're going to be stuck with this problem. Now, obviously, that presents challenges. And say with metals, you can use something like shock cleaning or something to introduce compressive stresses, whereas with composites, that's not really an option, which then means we need to at least know what the tensile stress on the surface is, so that we can then work around it. But obviously, if we could introduce compression, but nobody's looked at how to do that yet. Okay, thank you. Yeah.
Is any more questions?
Hello. Conference one.
So in the end, I would like to extend my thanks for outstanding and stimulating talks, wherein Professor Reed talked about fundamentals of residual stresses management in composites, and we must admit that it was done in a very lucid and illustrative manner. Well, eventually, on behalf of organizing team, I would like to once again thank you from the core of our heart for accepting our invitation as keynote speaker, and especially taking the pain for traveling all the way from Johannesburg. We are highly indebted for the act of kindness, sir, and we certainly hope that more such of interactions will be there in the future. Thank you so much.
Thank you.
Good afternoon, everybody. After this very insightful session by Professor Lee, we'd like to move on to the list of the next person, the eminent speaker that we have among us. So it is our pleasure to have with us Professor Sunil Pandey. And although he is an epitome of academic excellence, nevertheless, I'll give him a formal introduction. Professor Pandey is a distinguished professor in mechanical engineering in the Department of Mechanical and Mechatronics at the Inaugural Institute of Information Technology, Jaipur. Previously, he has served as professor in the Department of Mechanical Engineering at IIT Delhi as well as at Jawaharlal Nehru University, New Delhi. He has also held the prestigious position of Vice Chancellor cum Director at Slide Longowal. He holds the honor of doing his MTech in Production Engineering and PhD in Building from IIT Delhi. He has guided over 28 PhD theses and has published more than 50 research papers in renowned international journals. He has delivered numerous lectures and chaired more than 150 conferences and seminars throughout his career. He has completed over 9 national level sponsored projects and one international project is also there to his credit. Professor Sunil is Life Member at Indian Institute of Welding, Indian Welding Society, Life Member at Indian Society of Technical Education, Indian Society of Non-Destructive Testing. Adding to his brilliance, he has been awarded the Best Teacher Award by IIT Delhi in 2012. So the list of achievements goes on and on, but I feel immense pleasure in inviting Professor Pandey to come on with us and please share his views with our participants.
Light show. सेटअप सॉल्यूशन देखो ठीक अब आ जाइए इसको लिस्टिंग कर दीजिए पानी लेकर और फिर से टेबल पर
I am feeling really sorry for all of you that you might be thinking that this is going to be lunch time, but I am standing like a villain between your lunch and this presentation. So, but I hope that the effect of your late high tea will sustain you for this my presentation. And as you see, the title is Moving on the Highway of Innovative Research, Introducing Plasma Enhanced Sheeted Metal Arc Welding Process. The background of this moving on innovative research is all through my academic and industrial and administrative experience of more than 50 years. I have seen that we by and large are the forward research. That is, we pick up our topics for research and whatever we do from the literature. We do not spend our time in the industry. We do not try and find out that what our society needs. But we pick up threads from the literature and do some fill up what or filling the blanks, and that produces our research. So I never accepted this. Even when I started my PhD, I was against the literature survey, and my supervisor used to ask me, if Pandey, have you done the literature survey? I used to tell him, sir, I am doing. Because if I said that I am not interested in doing it, at the moment in I find a problem related to giving some procedure or technology to our industry and to our society. That was my objective. And keeping that in mind, all the PhDs we have guided till date, they are more than 30 now. They are all based on the indigenously developed technologies, not copied from any literature or any foreign university. But they are all developed while I was at IIT Delhi, and I feel very happy that all those topics which are picked up by me got awarded with the PhD. And in this, the idea came when we all start learning about welding technology. The first process taught to us is sheeted metal welding process. And then, by the time you complete the chapter, you are told that this process is getting obsolete and this is being replaced by some other welding process or MIG welding process or MIG welding or plus Kodak welding process. And when you see the cost of changing or switching over from SMW to this plus Kodak welding or Kodak welding process, it is involving cost. It has its own advantages, limitations, and switching blindly because somebody has proposed that this topic is more versatile than SMW process. So you simply also put your proposal to your administration. Yeah, I want to buy this, allow this much of funding, that equipment is imported and you start using it like a technician. Because you are not designing the equipment, you are not designing the technology, you are just trying to learn it. And using that machine, whatever work you do, you are only generating data and doing generally how to present the data and some software that is used, and that becomes a PhD thesis. That is where the talent of this country, we are immensely talented. You must have seen the progress of Indians when they work in the foreign universities or NASA or some other places, research activities. The same Indians, when they are able to do so much of work and they do that kind of work here. Because they are working as by acquiring the leadership quality in research. Here we are working as a follower researcher. That is what the others have done, we pick up that from there. So my strong suggestion, or I feel that we should try and pick up problems for PhD and Tech or BTech from our industries. Then only you will be able to bridge the gap between the academic and the industry people. And that kind of research work will be directly picked up by our industries and you will be able to feed them, nurture them, that will work as a vitamin for them. Right now, all the engineering graduates in the country, whether it's IIT, NITs or central institutes or whichever the university is, we are not sustaining our industry at all. Then we say the jobs are not there, we say that salaries are not good. Here is like you have some mango tree, let us say Alfonso. You have to nurture it. You nurture it very hardly, so that you keep getting fruits from it. But you only expect salary from the industry, you expect job from the government without realizing or without understanding that how much responsibility you are for this situation. Because until we start nurturing our system, whether it's industry or the research lab or research activity or teaching activity, it might be hard to sustain. And keeping this in mind, that since we are fortunate to be born in this country, why can't we do some soul searching and introspection such that we start directing or redirecting our activities and channel and energy in the area where we have developed indigenous technology, and that is where you will be sustaining our industry and the jobs will be permanent. No government in the world has any magic wand where you think that government says we'll provide 2 lakh job or 10 lakh job or 1 crore job. Where they come from? Until we learn to sustain the industry, and for this the onus again comes to the teaching community. Teaching faculty has to recast the curriculum in such a way that we are able to sustain our requirements of the society. Whatever we do in our classrooms, I'm sorry because I'm giving my experience over 3 years. Some of you may be little uncomfortable, but the fact is, the curriculum which we follow, what we teach our students in the classroom,
is not directly convertible into the industry. That's why our graduates seldom go to the industry. And if at all they go, they work on a very low salaries. So one generation has to say work very hard or say sustain or say do kurbani, and then only the next generation will be able to use them. If you convey that, I have no problem with that. So initially I had requested a time of 1 hour. I'm a very transparent person. Now I'm given a message that we have to cut short. So in fact I had demanded a time of 2 hours for my presentation, and I was given 1 hour by the organizers. I was still very happy that at least something I will be able to discuss with the audience. But now cutting it further down is the only option remaining now is that if I stop it in between, then you will allow me a playground again after lunch. Is that acceptable?
Yes.
Yes, that's right.
Right, sir.
Okay? So, thank you very much. So, keeping in this mind that when I was taught by my teacher that this process of safety radar welding is obsolete, the idea immediately came to my mind that India, that time, when I was in the school or college time, we were still a developing economy. We were not very rich that time. And our almost 75 to 80% masses of the country, they still stay in the villages or the non-city places like Kasbahs and small villages, etc. And considering their buying power and the economic capacity or capability, the idea came to mind that suppose we now change this process, we make it obsolete and pump new welding process for our villagers and the poor people. Will they be able to afford? Will they be able to maintain the equipment? The more equipment, the more parts in the equipment, the more maintenance cost is. The more chances of failure are also there. SMW process is a very rugged process. Let it be rain, let there be a dust storm, nothing will go wrong with the power source. But if you have a gas shielded metal welding process, the moment there is a wind drop, your gas shielding goes away. You will be putting only a scrap. So this process is not dependent on the wind draft because the shielding gas is produced right in situ. The moment you strike out, the shielding gas starts coming out, carbon dioxide in covered electrodes. So we were using this process for cutting applications. You must have all read this in your classrooms. We use it for cutting, and then there are variants where we say there is a process known as lancing process, there is a surfacing process, there is buttering process, there is a hard pressing process, then there is a process of creating alloys. We use various welding processes for that. The idea at that time came to me that if we are able to overcome the limitations of the assembly process, then there won't be any need to make it obsolete. We will continue to use it. And I also wanted to then bring more flexibility to the process. As well as process as such with the solid electrode is a very rigid process but very versatile compared to other welding processes. So I wanted to add versatility to the process to the extent that with the same equipment, same set of electrode, we should be able to do normal welding, deep penetration welding cross-sectional pipelines. We should be able to do surfacing, buttering, and hard pressing. We should be also able to do lancing, scarping, gouging using the same electrode, same setup of equipment. So if I was able to do this is what I thought at that time, then it would become a very versatile process, and every villager, every farmer, every small workshop person will be able to make more money because they will not be forced to maintain a large inventory getting to different application which I mentioned. So my objective was to bring flexibility and introduce these, compress all the variants in single set of equipment and power source. So this I'm going to present here, and this I will skip because the time is short. If you can quickly glance through it, it will be okay. This shows the importance of the welding technology in our life, our society, and even during the disintegration of the former Soviet Union and the unification of Germany, the Cold War came to an end. Billions of dollars became surplus with the US government because there was no Cold War, we had to spend that money. So, quite a big chunk of that money was diverted for academic research or scientific research. Major amount was given to NASA also. And after that fund, more than 60% of that surplus fund was awarded for welding research by the US government. And they adopted a slogan. It's not my slogan, it is written here. I have not written this. These are copied from the American Welding Journal, where the government of US had adopted in 91. The advancement or development of a nation or society can be judged by the advancements made in the field of welding technology. And what is shown in the background is the nuclear reactor, the space application, offshore application, then your automotive industry, rail, welding of rails, welding of ship. So much is dependence of big people on the welding technology. And without going further into this, the one statement which I can make safely is the welding is withdrawn from our society today. We go back to the Stone Age. Analyze. I will not say prove it through my statement, but that is the welding searches so much, it never demands its due. And that's why you also do not respect welding technology. But it is sustaining you to this extent that hesitation is there because of the welding technology. The mobile phones, all welding technology. Everything with laptops, computers. So everything is welding. Your shoes, your clothes, everything is welding. So this is the background of welding technology. And the world over, these 4 set of welding processes are used. SMW, also known as MMW, metal manual welding, stick welding, covered electrode welding. Then GMW is gas metal arc welding, metal inert gas welding, metal aggregate welding, plug core arc welding. They are basically the same category processes, varying because of certain changing consumables, but the same power source is used, same bar feeder is used. Gas junction arc welding or tungsten inert gas welding, the same process, and summary arc welding. Though we have more than 106 welding processes classified by the American Welding Society, but world over, so much realization has taken place, but the entire world is sustained by this 4 category of welding processes. This is what some of you will definitely appreciate, that what happens to any nation if you are dependent on the foreign technology. This is the outcome of that. You lose your self-confidence, you lose your self-esteem, you lose precious on exchange. So poverty takes over in any country where we are so dependent on imports. And that also gets you pretty complex because we will always say, yes, this is done by that person, not me. So when you are nothing to say that it is done by me, then where is the self-confidence or the self-esteem? We compromise that. Therefore, there is a need to dig into the quality of technical education system and teaching methodology and research. This I have already spent. So there are certain guiding principles which I always ask my students in every class to adopt to be able to sustain our industry and society. That is, be the leader rather than a follower. Innovate or perish. If they can, why can't we? ये सवाल अपने से नहीं पूछते हैं कि अगर वो कर पा रहे हैं हम क्यों नहीं कर पा रहे? हम नकली क्यों मार रहे हैं? हम इतने महंगा सामान क्यों खरीदते हैं जिसकी वैल्यू कुछ नहीं है? But because हमने नहीं किया तो it would be dependent. So we have to change this thinking process. We have to adopt the point number 1. Be the leader rather than a follower to sustain and succeed the nation. तो इसकी कर दूंगा मैं. Way out. If you do brainstorming in real sense, redesigning technical curriculum and teaching methodology, and every statement we make to the students, we have to be able to explain why and how. Why is that I have made this statement in the class to the students? And if they do not ask you, then get rid of them. Yeah, I have made this statement, not tell me why I have made this statement. If he is able to respond, it means he has understood, otherwise he has not understood. So this is how you have to make sure that brainstorming takes place in every class, every time we spend with the students. Otherwise our effort is going waste. There is a simple concept that can be adopted to become an innovative researcher. You have to first conceive the idea. And conceive the idea means you have to be in contact with your industrial partners, whichever area you are serving or teaching, design, thermal, refrigeration, air conditioning, welding, manufacturing, cutting, machining. So you have every kind of industry with you. You have to get in touch with your industrial partners, discuss the problems, and observe also yourself. They may not be able to say that these are problems they are facing, but observing their manufacturing technique with your knowledge apply, you can also identify that this is a problem which they do not know. You can discuss it with them, you can bring it to your lab, start working on it and give it back to them. So this will give you money, you become consultant, plus you are helping the industry to improve the technology which they are using. That will save resource, that will generate more money, that will increase the productivity of the industry. So now I say question my teacher also. When he taught me in the classroom that this process is obsolete, he never ever told us why this process is obsolete. He only narrated the things in the classroom which the people who have developed a new process, like big welding process, they introduced to the world and said, okay, now they earn money by remaining the leader in selling the consumers and power sources for SOW process. But slowly other nations also pick up. When they say the competitive edge is missing, the profits are dwindling, then they come up with a new process. Then suddenly say that process is obsolete, you have to use this process. So without questioning why are they saying this, can we not overcome the limitations, etc., etc. So we were taught this way only. This is obsolete because viewer says this. What can I do as a student? I was also not that mature that time. I accepted it, but when I came to this profession, I was not in a mood to tell students this is obsolete. Without telling them that why is this obsolete, so this was discussed. Then the idea of our discussion came to this, yes, I have to overcome this limitation. And if you do so, you will make the life of the villagers model. So this I can. This is our brainstorming. These names are already discussed or said in the beginning. So my objective was to carry out or perform all these various processes using a single set of electrode and equipment. So the first step was to identify the limitations of the process. But I was in a way of identifying the process limitations, I could clearly see that the limitations can be divided into two parts. One was operational limitations and other was the technological limitations. These are the operational limitations you can quickly go through. So much inventory is required in every process consumable to be maintained. Then they have shelf life. If you do not use them in time, then entire resource is wasted. And you need huge space also. And space is very expensive. Huge space is expensive today. So everything is coming under operational difficulties or limitation of the process. Suppose you are doing hard facing, you need a particular composition like some amount of chromium carbide on the surface. The electrodes are in the market, but that electrode gives you only particular composition. If you want a little more variation, if you want to have a little more chromium carbide, then you have to buy another set of electrodes. Like this, you keep on multiplying your resource and it keeps occupying the space, which is expensive. So the idea again came from this limitation that why can't we say develop our own computation, that computation right on the spot? Possible or not? It is very much possible. I'll tell you how. Operational limitations, then the profitability and competitiveness of the business. These are the technological limitations of the process. These are totally based on the research experience and going into books and say our own experience. So this is listing like this, you will find it difficult to find in the textbooks. Like the very interesting thing here is melting rate definitely is a limitation. You can't increase current to your desired level. The more the current, the more the melting rate is. But the flux gets overheated and the whole electrode is wasted if we do so. So our productivity is low. So this limitation is to overcome. What challenges can you overcome this limitation? That challenges you whether the Ohm's law can be defined, or is it possible to define the Ohm's law, or is it possible without defining the Ohm's law that I squared R heating is prevented? If that can be prevented, then you can use any magnitude of current with any electrode. But the conventional way Ohm's law stands true, it cannot be defined. But you can find a way out to prevent the resistive heating of the electrode when the higher level of current is allowed to flow through the electrode. And the length of the bed which you are making is limited to the length of the electrode. If I ask you that, not taking it to the global basis, suppose I ask you that from this NIT Jalandhar to the Amritsar airport, can you make a bed in a statement continuous without stopping the art using this technology? Looks impossible. Because the moment your electrode is consumed, you have to stop. So the challenge to you is, can you do it without stopping the electrode? Then, when the electrode is getting consumed, you throw a stuff. Some length of the electrode is wasted. Or when you are paid. Is it possible to use the electrode 100% in length? So, this is how the brainstorming is done. And when you do the brainstorming, solution is 100% bound to come. So if this process is saved from the obsolescence or the so-called obsolete process, the challenge is if you have to overcome the technological and operational limitation of the process. If you succeed, then you can challenge the people who say that this is obsolete process.
This are already discussed. Then we move into this.
This I already discussed that every challenge you have to discuss. If your answer is yes, then how to achieve? If your answer is no, then what will be the alternative? You do not stop your iterations. You will continue catching your mind that is brainstorming, and I can assure you that you will have the solution. You have to exploit the capability of the brain. You have that potential. It is possible. So, using this concept, I'm only mentioning the major contribution. There are a number of other processes and technologies which I have developed during my career, and I'm still pursuing the career. I'm still active in my research and teaching process. So these are the processes and hardware that I could manage or could achieve because of the taxing I did to my brain, and most of the students, they know this fully well. I'm proud that one of my star performer is sitting here, Dinesh Kumar Shukla ji. He gave me a opportunity to supervise his PhD, and he did work on a new technology, which I said I do not borrow the processes from abroad. I work on my own problems which I determine or get from the industry. He worked on one of the indigenous development process. So this is just a quick recap. This is the sheeted metal process in the simplest form. And let's take this of the advantages. You all know now. This is the modification as you have seen the title slide. The picture I show you again. But let me show that first. This is what you are seeing on the first slide. This electrode were designed and registered. This electrode which is connected to this is not a solid electrode. The only change which I did was solid electrode was replaced by a tubular electrode. And tubular electrode getting a tube made of electrode quality material was impossible for me. So I again first try to find where to get the pipes of this size, 3.15 millimeter diameter and 4 millimeter diameter pipes. I spent a lot of time in the hardware market in Delhi, and at one Kawaliwala, I saw a lot of coils Then I asked him, he said, these are the tubes. I said, some success is there now. But these were the tubes which were used in the steam engines for steam bypassing and bleeding, etc. So I said, I want to buy this. These are get rusted also. So I bought those bundles of pipes from the covering one, brought them to lab, straightened them, did the picking operation for remove the rust, then did the coating. I had a small experimental plant in my lab. So we were making our own electrodes. We do not buy, till the time I was in IIM, we were not buying electrodes, we were making our own electrodes. And we are making to the tune of like underwater wet welding electrodes also we developed. All experiments for the classroom was done by these local electrodes produced in the lab. So this coating was done, and then the electrode holder had a provision for the flow of gas. This is gas inlet, gas control valve. Then this is, if you want to feed the powder, I was just telling you that you have to change the percentage chromium or vanadium or any powder. You can do so, and this goes along with this orifice to the gas, and you can get any computation you want. So if you see the cross section of the electrode, this is solid electrode, that is conventional electrode, and this is the electrode that I only got this change. This is the schematic of the whole modification which was done in the sheeted metal welding process. Gas feeding provision was made, powder feeding provision was made, and then all the variants which I mentioned before, they were achieved using this concept. This is a detailed diagram of that electrode holder, which are fabricated and machined myself everything in the machining lab of the IT Delhi. No foreign technician or the outside technician involved here. So everything was done in the lab only. So these are the advantages if you feed a gas through the orifice during welding operation. I didn't know anything before that. After only doing the analysis of the welded component, I came to realize that what are the advantages of this modification. The gas was tried because you can feed CO2 again. CO2 being the cheapest gas, I recommend that. And using that gas during welding, here is the penetration behavior of the plasma enhanced sheeted metal welding process. You can see that even at 90 amperes going to 120 amperes, because 3.15 diameter electrode can handle current from 90 ampere to 120 ampere only. This is the relationship which I just shown. So if you are able to get the penetration behavior at 90 amperes, then this also allows you to use a power source which is smaller in capacity. It means cheaper, occupies less space, and the best part of this is the hazards associated with the welding are, that is UV radiation, is also low, because as you increase the current, the UV radiation also becomes harder and harder. So this soft arc at 90 amperes reduces the UV radiation. That, you know, we go to 4.7. Thank you. So this investigation is the second piece which I cut and polished. Realized that the penetration level is going very high. The mission arc welding, you get penetration level like 0.2, 0.3 or 0.15 millimeter only. But with this, we noticed that penetration was going more than 2 millimeters. And that was a wonder find, accidental find. I had no idea about this. But when we measured the depth of penetration, then the idea came, if this is the behavior of this electrode, by just feeding a gas during welding, So idea struck to me that when you cross-country pipelines, we use cellulosic electrode, which gives lot of hydrogen embrittlement in the joints, which make a lot of rework and the pipeline becomes very expensive and not very reliable also. So the idea came to me that because we use cellulosic electrode for deeper penetration, but that penetration is also not as equivalent to this 2 millimeter. So if we use rutile coated rutile flux for coating electrode or the basic coated electrode, which is also known as structured electrode, and this kind of penetration available, you can build cross-country pipelines with 7018 kind of flux. No hydrogen cracking will take place. There will be no rework required. And this is where I awarded one gave one topic to one of the research students, and we successfully completed the total investigation. And unfortunately, my retirement came and then could not exploit it further. But now once again taking up this process for exploitation by the companies which are involved in the laying of cross-country pipelines. And the person was Tiruchitram, who did the PhD. So this is the same thing, penetration behavior and graphical form. We can very clearly see that it is forced very clearly out the other convention method. This is a comparison of the weld produced by solid electrode and the hollow electrode, and 2.1, and that is 0.4 millimeter. So, so much is a change in weld penetration. So I'm trying to finish it before lunch so that you do not have to get bored again. This is a multi-million-dollar accidental find that new welding technology for welding cross-country pipelines using 7018 or 6013 type of coating so that we avoid cold cracking or hydrogen-induced cracking in the pipelines. So then it is a simple description through the orifice. If you feed the hard pressing powders, you will get the hard pressing composition on the substrate. If you feed only oxygen and do the casing operation, that is lancing, it is an arc lancing process. And if you feed the oxygen and do the gouging operation, that is also very simple, very fast. It is done at a very low current. It is a continuous process. And no carbon pickup is also there, because if you use a plane for doing the gouging operation, then there is a risk of carbon pickup by the weld method. But if you use the arc and any that 7018 kind of coating, which is the cheapest coating we think of, you can do the scarping operation, you can do the gouging operation. And this you say is the result of the hardness profile of the hard pressing operation done by in the beta nitrogen gas and nitrogen and chromium. So you will see that is the easiest way of getting any hardness. Then this also gave us the idea that instead of using a very expensive material for the entire cross section, wherever there is a need for a particular composition for which we use a larger cross section, we can produce an iron of synthetic matter. That is, using a particular composition in the form of powder, create a weld spot or the weld band, finish it. So that particular case we will have a desired composition. Suppose there are some mating parts where the wear takes place. So that particular area can be hardened using this process in no time. And instead of then buying the entire cross section of that, is not required.
Comparisons in wear group depth as a function of sliding distance for untreated and treated surfaces. Oxygen are cutting, like we all know that this is also used for cutting application, but we have a different cutting electrodes for cutting the plate. But using this oxygen through the orifice, you can achieve the same thing much faster because oxygen arc maintains a very high temperature that assists the rapid cutting of the metal. This is the actual picture of the technician doing a piercing of stainless steel 304 lot. This was 100 millimeter thick section. DHEL Haridwar. They had approached us for piercing it with this technique. So before this, we were not having the 304 of this size. So with one electrode, we consumed around 150 millimeter of length of the electrode and to get 55 millimeter depth we had achieved to the piercing. That is so much of depth we could penetrate. But we faced one technical problem there. The chromium oxide is very heavy. To remove that, we needed higher pressure of oxygen to the orifice so that from the sides it can pump out upwards. So that is again still an open topic for the research students or the teachers to try that how much oxygen pressure is required to go further below 55 millimeter. 55 millimeter achieved through normal gas only. But if you increase the pressure, the oxidation of the electrode also increases. So you have to strike a compromise between the consumption of electrode and achieving the piercing. But this is the cheapest method of making a drill hole in any section, like transportation of billets, blooms, etc. can be computed and by this process. Years ago, we do not have to need any drill machine or any milling machine or anything. Just use this technique, create a hole and hook it using a wire or etc. You can transport it. This is the gouging and scarping diagram. In gouging, we create a groove, whether full length or a localized groove, like we scoop out some metal using a flame. By scarping, we reduce the thickness of the entire section, like from this end to this end. This metal will be oxidized, so you will be left with this reduced thickness of the section. So this process is known as scarping, and if you do it by using the arc, oxygen arc, to tubular electrode, process is faster, cleaner, and you can save a lot of machining time or the welding time. Just read this, I think this will be the. I've tried to balance the timing. This is a small thing, 2 slides only. There is something guiding factor for you to work and to achieve set your targets. The last one is the one which I am following these days. Giving back what we have got from the society. यहाँ तक पहुँचे हैं, पेरेंट्स का कंट्रीब्यूशन है, टीचर से कंट्रीब्यूशन है, किसानों का कंट्रीब्यूशन है, इंडस्ट्री का कंट्रीब्यूशन है, तो वो सब इंटीग्रेट करके हम यहाँ तक पहुंचेंगे। तो मैं ये समझता हूँ कि हमें उधार लेके नहीं जाना चाहिए। जो कुछ हमने इस समाज से लिया है यही वापस करके जाओ। इस फिलॉसफी के वजह से आप कुछ कंट्रीब्यूट भी करोगे और पॉजिटिव कंट्रीब्यूट करोगे। अगर ये श्रद्धा नहीं है मन में कि मुझे वापस करना है तो फिर आउटकम में कुछ नहीं निकले। तो यू वांट टू give credit to your birth as a human, you have to adopt this principle. इसके द्वारा कुछ पॉसिबल नहीं है। Thank you. Now this is open to any, I'll say not touching questions if you have. I'll be very happy to respond and interact with you.
सर मेरी एक क्वेश्चन है।
हाँ प्लीज।
प्लाज्मा क्लैडिंग में हम थिकनेस माइक्रो लेवल पे अचीव कर सकते हैं सर?
प्लाज्मा क्लैडिंग में
जैसे सिरेमिक पाउडर की क्लैडिंग करना हो तो माइक्रो स्केल पे कंट्रोल कर सकते हैं थिकनेस को?
देखिए, what I presented here is the possibility of using this tube electrode for this application. I have not yet produced any PhD where we could measure what is the minimum, say, thickness of the coating that can be achieved. But if you are dedicated, you can definitely manipulate the welding parameters in such a way that the thickness can be controlled. Because by controlling the arc, you have to control the melting rate of the electrode. Deposition rate has to be controlled. So we have to go for the lowest possible current, and the powder that you are feeding, that again depends upon how much hardness you are looking for, what the wear resistance you are looking for, and how much thickness is required for that. It is possible. I will not say no, but I will still not produce the data on this. But I am confident if you are able to take up researches further, you can include me in this work. It can be done. But I have no data right now because I have not produced any data on this. We only produce that this is possible and we made the hardness etc. I have shown, but we didn't go into the case hardness. But one of the say graph which I have shown, the pink graph, that case hardness is given at 3 microns only. Yes, it was measured, but not extensive research is not done. But we could measure up to few microns only. The case death of the hardening process. Any other question? No questions? इतनी धूप तो निकल गई, बोल ही नहीं पाए आप लोग। हाँ प्लीज।
I want to know about the advantage of starting over milling because we can use milling for industrial.
This is a very valid question you have asked me. The advantage of milling operation. Now take a situation that you are working in general or working on a site where you must have seen a lot of welding goes on in the society or say in the city. So we have to reduce thickness of some section there on the site. You could bring the milling machine there. You can bring the hand grinder. That is possible. But bringing hand grinder, this process is much faster than that. Okay. So it all depends upon the kind of productivity you are looking for, the kind of surface quality you are looking for. But this process gives you all in one. You can do cutting, you can do surfacing, you can do piercing, you can do everything with this. So much of versatility is there involved in this. But on-site milling machine bringing is not possible. Transportation and mounting and everything. The lathe cannot be brought to the site. You have to do everything on site only. So this is where you have to judge what is to be done or what is not possible. Hope you are satisfied now. Okay, thank you. What can I do? सर कोई पूछ ही नहीं रहा।
Any more questions? So we are immensely grateful to Professor Sunil Pandey for spending his valuable time with us, and especially cutting short his presentation for the sake of lunch. We are immensely thankful to you, sir.
Thank you very much. Thank you very much.
And now we'll be moving for the lunch, and we'll be meeting back here only for another important keynote session, which will be taken by Professor U.S. So within half an hour, we'll be meeting.
सभी लोग लंच के लिए अपने आइटम में चले गए।
ਵਾਲੀ ਕਿੰਨੀ ਸੋਹਣੀ ਹੁੰਦੀ ਅੰਦਰ ਬੋਤਲਾਂ ਤੇ ਚੱਕ ਦੋ ਹਾਂ ਕਦੀ ਇੱਕ ਵਿੱਚ ਚੱਲ ਗੱਡੀ ਦੀ ਤੇ ਆਹ ਚੱਕੋ ਬੋਤਲਾਂ ਆਹ ਤਾਂ ਸਾਰੀਆਂ ਭਾਈ ਫੋਟੋ ਖਾਈ ਜਾਂਦੇ ਤੇ ਇੱਥੇ ਖੜ ਕੇ ਕਰਾ ਦਾ ਇੱਥੇ ਨਹੀਂ ਇੱਥੇ
ਬੈਠ ਕੇ ਉੱਥੇ ਕਰ ਲਾਂ
ਉਹ ਮੈਪ ਚੱਲਦਾ ਆ ਭਰਾਵਾ
ਦੇਖਦੇ ਆਪਾਂ ਕੀ ਕਰਦੇ ਤੇ ਫੋਟੋ ਦੇਖਦੇ ਅੱਛਾ ਲੱਗ ਜਾਂਦਾ ਨਾ ਬੰਦ ਹੋ ਗਿਆ ਅਸੀਂ ਕੀ ਕਰਦੇ ਆ ਭਾਈ ਲੈਪ ਹੋ ਕੈਮਰਾ ਹੋਣੇ ਆ ਆ ਦੇ ਇਹ ਝੂਠ ਨਹੀਂ ਹੈ ਝੂਠ ਨਹੀਂ ਹੋ ਰਿਹਾ
ਬੰਦ ਕਰ ਮੈਪ
ਪੂਰਾ ਮੈਪ ਦਾ ਕੀ ਹੈ ਨਾ ਸਾਰੇ ਚੱਲਣ ਦੇ
ਹੈਲੋ ਬੰਦ ਉਹ ਤਾਂ ਇਹ ਬਾਹਰ ਜਾਂਦੇ अब बोतला चक ली मैं चला है मैं भी खानी है चलना आया वाह
तो आगे रहने पियां मतलब
यार वो फिर आके बैठ जाएंगे आया मैं खाई
मैं नहीं लेना मैं खा लिया
वो जो ही गाने
पर ना भरावा
आज भी चकला
खाली बोल चक लेना मैं तो काफी अब क्या
ये चीज है।
उनके पास वैल्यू प्रोग्राम है यूनिवर्सिटी टीचर ग्लोबल ग्लोबल बाकी में जब मीटिंग में आ जाता है तो मीटिंग में कहीं कहीं पैसा ले लेता हो जाता है ये प्रॉब्लम है अच्छा हो जाएगा खराबी हो जाएगा उन्होंने सफाई करी गवर्नमेंट का असर लगाती है खाते लेकिन कई लोगों ने क्या करना पॉलिटिशियन को खिलाना गवर्नमेंट में तो घाटा ही तो हर बार तो टैक्स में से बजट में करते हैं कि इतना घाटा हो गया ये बताने वाली इसको घाटा जो करेगी इन्होंने तो जो कमाए उसमें
और सड़कों पे जो टोल टैक्स लगा दिए आप देखो मतलब अगर रोड बहुत ज़्यादा मतलब गैस में और 5 किलोमीटर 10 किलोमीटर मतलब आप गाड़ी में जा रहे शेप बहुत ऐसी आप जैसे हमें फाइल पा रहे हैं कितना टाइम ऊपर जैसे बिजली कर दिया वो ऊपर सारे लेट हो गई जो शाम तक काम करेगा उसको कम नहीं आएगा जो 300 से ऊपर अच्छा इसलिए आप पावर कट होगा हॉस्पिटल रहते हैं तो करते लगते हैं अभी शहर में तो आ जाती है ये देखना चाहिए कि पॉलिटिशियंस है इसमें विश्वास वैसा पैसा है जहाँ भी जाएंगे उसकी कंपनी दूसरी कंपनी वो कैरियर बन गया जैसे पहले की दूसरा जमाना है उनके लिए वो बिजनेस है वो तो मुझे लग रहा है कि सिर्फ डॉक्टर लोन से थे जो वैसे या अभी कुछ हद तक रिवाइज भी कह सकते हैं लेकिन वो थोड़ा सा गड़बड़ और चंद्रशेखर हो गया ये जो रंजित राव थे ये अच्छे प्रधान पूरा एटलीस्ट इनका कमी पे होता था इनका कमी के और हमको भी लगता है कि वाइट मिनिस्टर वाइट जो है मोदी जी का पीरियड बहुत अच्छा था और जो सीधे आती थे फालतू बातें नहीं करती एक्चुअली जब इन्होंने बोला ना वो चक्कर बना था कंपनी बोला था जिस ढंग से कोई बात बोला था मैंने पहले क्रेडिट कर दिया था कि ये इसकी सीधे जो है हम जाएंगे समझ सौ की सौ की पता क्या वो भाई दीदी गई इस टाइप का ये चंद्रशेखर के चूल्हे छोड़ना ये करना मजाक में बैठूं अब नेहरू को इतने बात सीखना ठीक नहीं मतलब ठीक है आप अनेक प्रधानमंत्री एक तरफ कहते हो कि हमको अपने देश के हिंदुत्व वाले हैं वो इस चीजों को पसंद करते हैं आप जवाहरलाल नेहरू को अपने प्रधानमंत्री ना वो अपनी बेटों का सम्मान करो है ना मतलब आप उसको पीरियड की बात करके वहाँ के ऋषियों का सम्मान कर रही हो, नेहरू जी, इंदिरा गांधी सब बड़ा पीरियड है, आप इनको आप कुछ भी नहीं कर रहे, या उसके पहले जो अपने देश की बेइज्जती है ना, जैसे कांग्रेस ने इतना किया था, वो ऐसे गलत रहना चाहिए था। वो अटल बिहारी वाजपेयी ऐसे नहीं बोलते थे, सभी सभी सभ्य बहुत ही गहरा है सारे राष्ट्र ये गुंडागर्दी और तमाशबीनी ये सब ऐसे वाले ये काम करते हैं। तो वो जुबान से एक जुबान से कुछ बोलने खासकर किसी मनुष्य अपने तो वो हर बंदा आपको सुनता है और उसका बच्चा को सुनता है। तो उनसे तमाशबीन लोग वहाँ पे बहुत अच्छा वो भी करेंगे, उनको देख के ये नहीं कहा जा सकता कि मैं जो कह रहा हूँ सही। उसकी बॉडी सुन के पढ़े लिखे लोग, संगीत वाले लोग जो बैठे हुए हैं, जो मतलब सीरियस लोग हैं, जो देश का बनाना चाहते हैं, हर किस्म का वर्ग का लोग जो उसको सुनेगा तो कैसे रिएक्ट करता है, कैसे एक्सेप्ट करता है, उसको एक्चुअली का लोग को ऐसा नहीं करना चाहिए। मतलब अभी भी वो ऐसे जैसे पॉलिटिशियन हो गए ना, काम करने के लिए वैसे अगर चीप चीप लोग को पॉलिटिक्स कर देगा, देना चाहते हैं, इस तरह से बोल रहा है, देश की रिस्पेक्ट नहीं कर रहा है, वो करना कोई बात की गलती बोलती जरूरत, जैसे कोई बात ऐसा पंजाब के ऐसा बोल जो कि लेकिन इसका पहलू ऐसा ऐसे दुआ देते क्यों आप तो उसका ये उसका समझ नहीं पाते, उसको क्या मतलब मीठे ढंग का लिखने का चीज होगा। हाँ, ये एक गलत बेसिक है देता है। भाई ये लोग उसे सावधान रखना, उस भाषा में जैसे आप ऐसे बोलना चाहिए, उसी प्रति बोल नहीं जाते हैं, वो कहते हैं कि है ना भाई को ये सब इकट्ठा हो गए हैं, बाकी चीज गाँव जाती सिटी में है जैसे कि रोटरी है जैसे ये कॉलेज है अच्छा इस टाइप से रोड के ऊपर हेड क्वार्टर में इसके होगा 5 किलोमीटर हाँ जो यूनिवर्सिटी से हम लोग बाईपास है एक थोड़ा सा आगे और जैसे ये ऐसे ये आगे ऊपर के ना जैसे आगे बदल होना अच्छा बदल अपना गाँव का हम इंग्लिश वगैरह अच्छा है कहीं ये प्रॉब्लम हम प्राइवेट सर्टिफिकेट कर लाते विशेष चल रहा है बीजे कॉलेज में बीजे को छुट्टियां चल रही ट्यूशन हो जाती है बीजे किसी के पास आगे बीजे की ऐसा नहीं CPIE होगा फाइल है उसको ठीक है ये है ना इसमें CPIE 2020 की दीक्षित बस इसको उठा के यहाँ रख दीजिए बस क्योंकि मुझे क्या है वो आप दे दीजिए बस ओके बस ये आएगा तो इतना हो गया ये तो उसका था इनका था मेरा CPIE ये है नहीं मैंने यहाँ डेस्कटॉप में रखा ना ये कहाँ जाओगे हाँ ये है
ज्यादा तीन से कर दीजिएगा। हाँ तबीयत ठीक है। आपका कांदी सब नहीं है, माता की बड़ी की माता की हॉस्पिटल में प्रैक्टिस
अगली प्रेजेंटेशन होगी 40 मिनट की। ये क्वार्टर डेमो होगा।
ये सब कर सकते हैं।
वो फर्स्ट जानी स्क्रीन में है तो फिर ना क्वार्टर की कोई हो तुम दे हो नहीं जूम करना वाले बोली छोटी सा स्क्रीन हो चलिए बोलते मैंने कल नेक्स्ट बॉक्स बट वो फॉल्ट डाल आगे एक छह फोटो तो रीच नहीं पहुंचे तो कोई इलाज नहीं है। कोई परफॉर्मेंस ऐसे है जिदा अवस्था हर भी खड़ देसी ना तो वो झुक के खड़ देसी वो कर ले भगवान का खाना पता नहीं कुछ नहीं जगह पर लगाई साहब
more than 250 publications to his credit in various internationally recognized journals and conferences. He has guided more than 20 PhD students and 50 master's students. He is on the editorial board of many of the reputed international journals. Professor Dixit has done around 15 projects funded from reputed agencies. Many of the projects are being collaborative in nature. His collaborations is with various Indian institutions as well as with different foreign institutions. So I request Professor Dixit to please come on the dais and share his experience with the participants.
Thank you, Dr. Verma. Okay, I will be giving a brief talk only, maybe. If you just, I hope in a target half an hour. But if you want to cut out just 2 minutes before you indicate, okay, because any time I can stop for presentation. I just want to insist that how you should orient manufacturing education changing time, okay. So before we do that, let me just tell that I have written many many books also, particularly some books you are seeing here published by Springer. Most of my books are in fact expensive and we kept only in libraries, and you can recommend it there and you can study. But recently I published one book from AICT actually. This is on the strength of material. I am highlighting this because you can download without paying anything actually. So a lot of people have downloaded in AICT. There is an e-book portal. They are not only my book but other similar type of books are there and you can easily download. That is what I want to tell. And then just for the information of some others that I not only I write the technical books related to mechanical engineering, but lot of story books in Hindi. Okay, so these books are also, some people they study, particularly Vishal Sharma has got by some of the Hindi books also. So then I thought that how industry, since I take interest in creative writing, so why not I first start my, because talk is on industry 4.0, so I should write a poem. Okay, so I wrote it. So this is industry 4.0 in a poem actually. So industry 4.0, the new age has begun, where machine meets mind and work is fun, data drives decision, automation moves, efficiency increases and waste reduces. From smart factories to predictive maintenance, the fourth revolution takes us to new advancements. Let us embrace this change with open arms and pave the way for future that is full of charms. So this is a quote. Okay, so you got happy, and because it covers all the aspects of that. But then a big shock is coming to me. It is not written by me, but it is written by Open Chat GPT. Okay, because that's what I want to highlight. That the coming time will be like that. That because machines are going to work with human beings, you will not know whether the machine has done or the man has done. But you can't avoid that. So that's what I am telling that Chat GPT is a generative detailed transformer and it is a language model. So it just interacts like a human being. What I do, I said to him that I want to go to IIT Jalandhar and you will talk in industry 4.0 and you write a poem for me. then I wrote that this one in chat. I said, don't give this poem to anyone else because I will tell that this is my poem. They said, okay, fine, but it is better you can acknowledge me. Then it is this one. So that's what I am telling, the time is coming like that. So it is, impact is so high that I saw recently that in Elsevier journal publisher, he has written that in instruction to authors that how he said that you can use Chat GPT, but please acknowledge, you mentioned that if there are practice, so let me just read something for you. Applying the technology should be done with human oversight and control, and authors should carefully review and edit the results, because AI can generate authoritative sounding output that can be incorrect, incomplete or biased.
the authors are ultimately responsible and accountable for the contents of the work. Authors should disclose in their manuscript the use of AI and AI-assisted technologies, and a statement will appear in the published work, declaring the use of these technologies supports transparency and trust between authors, readers, reviewers, etc. So the idea is that because many people started telling that I have taken help from ChatGPT and I want to put the name as a co-author. Because if you see the system, so they are saying that AI assisted authors should not use AI and AI assisted technologies as an author or co-author, nor cite or AI as an author. So this is taken from the HTML website. So this is the impact of this thing. Means time has come, whether you like it or not, but it has to be. Now there is a question all of us to introspect. When I wrote this poem, then I thought that, okay, is it that I myself would have written, but it may have taken 1 hour. So and this poem that ChatGPT composed in 2 minutes. So the question is that if you would say that no, I will not take the help, then your computers will be ahead of that. And if you take the help, then also there is a danger. Many times your own creative skills will go. So the technology has to be used with caution. So that's what. So that's why I am just telling that about the revolution. Just there are some slides about that. First, usually it is a cycle of 100 years. First industrial revolution was in the period 1760 to 1840, and it is the time when mechanical engineering got popularized because of the steam engine, etc. So, first industrial revolution means mechanical engineering, and then you got second industrial revolution, that is 1870 to 1914. Here, electrical engineering became prominent, and in fact, the concept of mass production, etc., and also came. And that's what industrial engineering also became popular in this period. Okay, so these are the pictures. Then the third industrial revolution is considered this period 1970 to 1999, something like 100 year period. In this period, electronics and computer assisted machines, they became important. And now, finally, fourth industrial revolution, which is present just after 50 years, it has come. And people are telling that this phase is going on. In that, there are many things. So there are, if you can see, there are many technologies here. That one is, of course, cyber physical systems. Then you have mass customization, 3D printing, etc. Then resource efficiency, Web 2.0 and Web 3.0. Web 2.0 you may be familiar. That is content in which you can interact actually. Like example is Facebook, etc., where you can do input. Because earlier when the internet came, then that time it was static type of thing, that pages are displayed. I can put my article and anybody can download that. But the second one is that you can yourself fill up the data and you can do chatting also. And the third page will be that in which there will be AI and all those type of things. And this is smart food, then additive manufacturing, autonomous manufacturing, cell, digitization, digital twins. That means it is the age in which on each and every process you can make computer avatar of that. Okay, miniaturization, smart factory, importance of AI. So these are briefly that it is showing that industry 4.0. So first page is showing that this is showing steam engine. Okay, steam basically pump. Then second is mass customization, and the third is robotics, etc. And fourth is now this is interact cyber physical systems, and even concept of metaverse, etc. is coming. Now digital twin means recently the digital twin concept was given 2011 actually, 2011 in Germany. So this person actually first gave the concept that Pagan, and this one. So after 10 years again, he has written one paper, which is published in Open Access Journal, and in that he has said that in 10 years what we have achieved. So here he has highlighted the use of digital twins actually, which has come as a part of Industry 4.0. Digital twin concept was used by NASA also. that this rocket is going and in virtual space also you are making the same thing. And with the help of sensors, you can get feedback, etc. That you know this one. In fact, one can get digital twin of mind also. Instead of I giving a speech, my digital twin can give a speech here, and it will be like a real one. This idea that digital twin can be even this one, all the characteristics can be there. And this is again that there is iron link that is also shown as a digital twin, or it is something in the physical domain also it is shown. So then another thing is the role of the cloud computing. In fact, long back I had guided a PhD thesis on the use of cloud computing actually. In that you have all the data, even the hardware computations, etc. You are doing in the cloud actually, and it is coming in this one. So that is also has come actually many type of things we need to be there. Then soft computing, application of soft computing, it has again picked up, and you are having data given by modeling, etc. And this is the concept of online optimization of machining process, that where you take all the information when you are doing the machining and you collect the information, and again you can take the corrective action. So and this is cloud computing based optimization. So here all these type of things, some of my students, in fact nowadays boundaries between disciplines are changing, because this has been made by, I have guided some students on computer science also. And then human computer interface. This is online learning, concept of online learning, that means you are learning like a human being. So this is one thing that we have made one type of system, that suppose you want to do some particular job, this is applicable to many things, not one particular production process. Then you have to do hit and fire type of procedure. So suppose you want to produce some component, so you have to do 5 type maybe simulations to find out that what is the proper parameter. But as you do the computations, then the data is not wasted. In fact, the data is stored in the system. So therefore, it keeps going again and again. So next time when you do that, next time it could be done in 4 simulations. Then after that, it could be done in simplest number of simulations, and I believe you can predict in 1 simulation. So this is the concept of online simulation of anything that it can be applied to welding, it can be applied to forging, many processes. So then this is my present student is doing work on the application of big data in manufacturing, that collecting the big data from various factories and then taking the system. And this is about the how you can do the data management. There are a lot of interesting issues which may be very interesting to production and industrial engineering department more than technical. You can decide, because the issue is that it is not just the data, but a lot of data reliability there. You have to do data filtration, then you have to see the reliability of the data. All these aspects are there. So after that it becomes this one. So these are the challenging issues. That means which you one can take up on each topic. One in fact can do one PhD. That handling of outliers, then data security, then avoiding data explosion, then dealing with scarcity of data, assessing veracity, that means reliability of the data, then efficient way of prediction, that means whether it can be done in piecewise linear way or it can be done in any other way. These are the main issues which I have highlighted here. And then but the question is that after everybody is talking about that and which software how come, and people talk about digital twin also, so many things, but how it can be a reality. So in that you have to be very strong in modeling and simulation, because that sits in the core of that. Modeling and simulation can be physics based or it can be data driven based, and best thing is to use the hybrid approach, that it should be data driven as well as the hybrid one. So physics of the process should be understood clearly. Then another thing is the cloud based design and manufacturing. So why do we model, generally why do we model any process? These are the main motivations. You want to know that what is the power requirement. In metal farming, you want to know what is the pressure in the dies and tools, what are the stresses and strain, what are the residual stresses in the product, what are the defects, what is accuracy, what is surface integrity, then mechanical and metallurgical properties, then microstructure. Lot of things are still unexplored and scope is open. In fact, I have against from top to bottom. So the top portions have been more or less been done, but at the bottom there is lot of scope. That means power requirement etc. is easy to find out. You can do residual stresses in the product that also can be modeled, but modeling of the surface integrity in any process is still very challenging. Be it machining or be it welding. If I say that what is the power consumption in the joining, that is easy to calculate, but what will be the surface finish, that is difficult. Then mechanical and metallurgical properties, that is even more difficult. Unfortunately, because in metallurgy, many people are not doing computations. Then microstructure, that is really difficult. So these are various methods I just listed. Some of these methods have become somewhat obsolete, but still may be useful sometimes. Like one method was slab method, where we keep maybe small slab of the product and then make a differential equation on that slab. This is an analytical method, has got limitation, but is still very handy. Then upper bound, this is used very often in the plasticity metal forming, that in which you find out by that you can predict that your load will be not more than this particular value. You will not be able to tell the exact load, but you can tell by upper bound that this is the upper limit on that. It is very essential to know these type of analytical calculations also, because it can validate your FEM model sometimes. Then lower bounds program slip lining highlight element method, which has become very popular since 1970. It came now, it is almost 50 years have passed, but it is becoming a very popular difference, highlight volume, boundary element method, and these are upcoming methods, molecular dynamic simulation and crystal plasticity. So molecular dynamic simulation is a universal type of simulation method. You can model any process and you need not know anything about that actually. Be it machining, be it metal forming, it is area independent, but because you see molecule wise what is happening. But there is a lot of drawbacks, because practically any practical process if you want to do by molecular dynamic simulation, it may take you 1000 years also. So right now, what is the present stage? In the present stage, people are doing very simple problem, and by unnecessarily giving very high strain rate, so that simulations are finished in less number of times. They are not giving much realistic things. They are more of academic interest, and even then they take about 7 days, 8 days to do one simulation. But if you want to actually model that one process, it will take this one. Then another one is crystal plasticity, which will not take that much time as the molecular dynamics. You can combine it with FEM. Here you see at the level of the crystal. Okay. So this and then if you want to do modeling, anybody who wants to do modeling, then he has to. You cannot say that okay, I will do only this one solid mechanics, I will do that. You have to do even heat transfer also. So in a way that those people in production or industrial, those who do modeling, their job is in fact more difficult, because you have to even thermal modeling also. So you have to see heat transfer and all those type of things, and then you have. So we have got one setup at IIT Guwahati. This is a rolling mill. In fact, this mill also I got made in 2002 in this one, a MTech project. वहाँ का शर्मा जी है ना, DK शर्मा, विशाल शर्मा जी. So he made that machine, one setup, complete setup. Only thing that loans were donated by a company. That he wrote he wanted to purchase. Company said no. If you do at least purchase 100 pieces, then we'll do. He said no, it is found by MTech. Then they said we will do free of cost. Okay. So then they came and we fabricated. So in that we did some experiments. and that here it is showing that concept of that inverse estimation. Many times you don't know the property, material property. So one more interesting area which can be useful for anyone, particularly processes like building etc. It is even more important because if you want to do proper modeling of the building, in which you will not do only heat transfer modeling, but you will want to find out what are the residual stresses etc. So lot of mechanical engineering concept is there and related to solid mechanics, but you don't have material properties and you don't know at that temperature what happens. Maybe at room temperature you might have studied, but what happens at 700 degrees centigrade. So you can use the inverse method. So here by putting some camera and some infrared sensor and velocity sensor, we are seeing that what are the characteristics of the process, and then I am going to predict that what will be the property of that. Means I am not doing any material testing. Material testing is done by measuring the temperature etc. Like the doctor measures the temperature by thermometer and then he says that this must be the thickness. So we measure the temperature and we tell that this must be the property of the material. So this is the method that involves determination of heat flux and thermal properties, that you are just measuring the temperature and then with the help of finite element simulation, then you can predict that what must be the property. So it is inverse problem and it is basically a type of optimization. But there are some issues because your solution should be unique. So how many measurements you have to take so that your solution should be unique, and what should be the location of the sensor, what properties should be tested, these are the issues. This is, I have seen lot of people keep doing work in the machining actually. It is somewhat saturated conventional machining, is it not? But the residual stress studies have not been done much actually. I am telling that people have lived the difficult part. So residual stresses in machining is still a very challenging topic. Even if you want to do by computer simulation, it is still a very challenging problem. Then residual stresses in building, okay, that also is the area which has to be done. So how do we estimate residual stresses? One needs to do elastic plastic analysis. There are, in APM, it is very challenging, and we had done some work in the past, and about the measurement already that in the morning, Professor Robert Reed has given a talk, and he has told about the measurement in the composite materials. But even measurement in the metallic materials is also very difficult. I hardly find any place that where you can measure residual stress reliably. Because there are, say, you can measure by X-ray diffraction. Some people have that facility, but the problem is that it can measure the residual stresses only on the surface. And then there is a technique of neutron diffraction, but neutron diffraction is even expensive. And again, they can have deeper penetration, but again there are many issues. So there are many cheaper methods have been developed. Still there is a lot of scope. Okay. Then multi-scale modeling, because you want to model, so again use of crystal plasticity etc. comes. So here I am giving one concept that it is hybrid computational technology. That means you use finite element neural network and all other techniques together. I have time or something, okay, just keep telling me more. 5 more minutes, okay, fine. So this is hybrid computational technology, like by Ethereum, I am getting some data, and with that data I have trained my neural network. So my one Ethereum modeling takes about say 2 hours, but lot of data has been used and it has been trained. So next time it can give a guess value to me, and then the prediction can be much faster. Okay. So this is the Ethereum simulation of friction stability. Okay. So nowadays this we know that with the help of the packages, and this gives you roughly some idea about time. Now here if you do that, say something like 5 hours, then dwelling 3 hours, and this is flavors 10 hours, total 18 hours. That is the order of the simulation time if you want to do something in this world. So although we are getting many things, big things, but we have to face the challenge. We are getting ready-made answer very fast, like I showed chat GPT, it does job in second. But if you want to make your own model, you can imagine how much time it will take. Okay, so that means it is very expensive. There was one more technique of meshless method. Because using in a here you have to make elements, but in meshless method you don't have to make elements, you only have nodes. So in 2000 there was a big hype about that meshless methods will be very useful, and then this one in 2000 one book came and it was by Leo that moving beyond Ethereum. But present state is that even in that also there are many methods, but they take a lot of time, computational time. We had done some work in 2003, but after that, no student has taken up that type of work because suppose you do some job in Ethereum by 1 hour, it nowadays also takes 4 or 5 hours in the meshless method. So that means many times you have to struggle a lot. But this happens with each and every technology because 3D printing has become really popular now. But it is there was a time that when it came and there was a big hype that it will be captured, but after that about 10 years there was no activity in that direction. That time it was called rapid prototyping. So I don't know that in future meshless method may become popular, but we did somehow coaching simulation by meshless method. Then this is the joint paper of myself and Anish Rai, who came once here and gave a talk. That molecular dynamics, we compare two methods, molecular dynamic simulation and crystal plasticity. So these are the some machining regions. You know, single crystal, this one, and then after that, this is by crystal plasticity Ethereum. Okay, so these two regions are shown here. So here there is a conclusion that molecular dynamics is useful when deformation mechanism is not very well understood. That means MDS can be applied in any process actually. So it is process independent. But then it gives fundamental insight of the deformation processes. No prior knowledge of system evolution is required. These are the positive points here. But negative point is that it is increased complexity of the potential and computational cost for multi-component system. Lot of computational things is there. Time, scales and domain size are very limited. Nowadays people just take that artificially something like 100 nanometer size. Okay, they will not be able to do complete machining. They will take a maybe job of 100 nanometer diameter, but you can know that practically 100 nanometer diameter is of not much interest to you. Even time wise also they will do simulation only for few microseconds. What happens in 1 microsecond? But this may not be of interest. Unrealistic strain rate far from real world situation simulated. That means in machining process, maybe actual strain rate may be of the order of 10 to the power 2 per second or something, but here you have to, if you do at that strain rate, it will take lot of time. So they increase the strain rate. Then crystal plasticity Ethereum, where you simulate the crystal, it is computationally more efficient. It is its capacity to model reasonable spatial and time domains. Then various deformation modes can be modeled. Then materials with different crystal structures can be modeled. FCC, HCP, BCC, anisotropy can be modeled. Deformation mode dependency on various parameters can be incorporated. Then capability to investigate individual deformation mode. But on the negative side is that you should have this one models are each and every situation. That means it is like semi-empirical kind of approach. You should have something about material behavior, advanced identification of deformation modes and calculation of material model. So lastly, that you know few points about that industry 4.0 about 3D printing. You know nowadays lots of 3D printing processes have been come and they can be classified depending on the raw material like solid based, powder based, liquid based, and then based on the layer formation. So these are the processes which you know. Selective laser sintering is very popular. It can be used to make metallic type of objects, also metal powder. But when you study the sustainability of the process, you have to consider that how much energy goes in making the powder of the material, and then what will be the residual stresses, etc. So selective laser centering 3D printing means this is actually called 3D printing, but nowadays UV process is called 3D printing. That was just like a printer, that powder will be coming, and then you will have in between you will have a tissue binder and it will join. Then laminated object manufacturing, where you have sheets, they are cut by the lasers and they are joined together. And then you have got laser engineered plate shaping. And this is one process, gold metal transfer, what they are building. This is an excellent tool for 3D printing actually. Gold metal transfer technology foundation, because you are expert of that. I was always thinking, and foundation also says that because building is always dependent on the skill of the builder. Builder was very important. In machining we could do automation, but even now practically in building automation has not been done. But when I saw this in my institute that machine was purchased, then I thought that maybe after some time the builders may also become jobless. That type of situation is there. But it is totally controlled by the computer, and it is a gold metal transfer. It is basically a big process only, but big with very low current. What happens that the electrode, when it touches the one piece, then their short circuit takes place. That time suddenly the current drops, and then this is wire is basically feed wire is retracted. This one by mechanical heat. So that type of, because so motion is not be, because normal heat process the wire is only coming in one direction. Here it comes, hits it, then again comes. So it is so fast that even the 3D printing objects can be made in say something like 2-3 minutes. One object which I made in FDM in 45 minutes, same could be prepared here in 3 minutes actually. And that is this one. So I was always thinking that how the 3D printing will become competitive. But seeing gold metal transfer building, I have a lot of hope that it can be in fact become competitive. So this machine in fact we purchased in IIT Guwahati that the powder with fusion based 3D metal printer. In this you require a lot of powder. But I would say that CMT is much better than our this type of machine. This machine is very expensive. It is about 5 crore rupees machine. But 5 crore rupee machine, then you need powder also. Not everything you can make, but there it is very easy because feed wire is there. You just take wire electrode, it keeps on depositing, and this CMT can do that. So I hope then we can do even concrete printing. I have one faculty member with me that works in 3D concrete printing. So they extrude the concrete things. You see with concrete, cement, they have written IITG. So this machine is very simple device, and we are going to do some modification. There is a DSP project in which I am also involved. And so there are different processes of 3D printing are there, but there are pros and cons. Particularly time is less, so therefore I just draw your attention towards the layer thickness. Because layer thickness is very important parameter. If you can get very small layer thickness, that means you can get a precision product. But here now limitation is that in extrusion type of process, layer thickness is 100 to 250 micrometer. Material jetting it may be even 5 micrometer, and then powder bed fusion, that means 3D metal printer, that is 25 micrometer, 75 like that. And these are this one. So these are the general description about the various type of processes. And okay, I think I will skip that. So now the issue is that current research in additive manufacturing should focus on these aspects. How can it be compatible with other manufacturing processes? That should be the focus of, I think, production and industrial engineering department and those faculty members. Means because issue is that speed, whether the 3D printing can produce the parts with the same speed, then mechanical properties of characterization, then cost, availability of raw material, because you cannot take just any sheet and you can make, because again you need different type of 3D printer, then overall sustainability. So now I will end my talk with the just pointing out towards National Education Policy 2020. So because how much emphasis it is in fact given to these type of things that industry 4.0 related concepts, that this is in introduction it is written that with various dramatic scientific and technological advances such as the rise of big data, machine learning and artificial intelligence, many unskilled jobs worldwide may be taken over by machines, while the need for a skilled workforce, particularly involving mathematics, computer science and data science in conjunction with multidisciplinary abilities across the sciences, social sciences and humanities will be increasingly in greater demand. So this, whatever is written in the national education policy in introduction, it is relevant for all of us because that's how the mechanical engineering curriculum has to change. That in manufacturing, you have to impart more mathematical skills, more programming skills. You teach the traditional subjects, but you cannot do away with this one. So that's what it is written here. Then in 4.25 section, policy says it is recognized that mathematics and mathematical thinking will be very important for India's future. So this means it uses about computations, mathematics and computational thinking. Then in 20.6, it is written that India must also take the lead in providing professionals in cutting-edge areas that are fast-growing problems such as artificial intelligence, AI, and 3D machining. I think this is a misprint in that policy document. It should have been 3D printing, but they wrote 3D machining. Anyway, big data analysis and machine learning, and this is this one. And in introduction, it is written education thus must move towards less content and more towards learning about how to think critically and solve problems, how to be creative and multidisciplinary, and how to innovate, adapt, and absorb new material in novel and changing fields. So that is the message here. And multidisciplinary and holistic education across the sciences, social sciences, arts, humanities, and sports are multidisciplinary work in order to ensure the unity and integrity of our knowledge. So that's what the concept of like mechatronics, and this is about holistic and multidisciplinary education, and about this one. So final points. So it is that this one we want to say that interdisciplinary learning should be encouraged actually. That means this is very important if we want to survive. Nowadays in mechanical, people are taking less admission in private colleges also. And this is, and now you have to adapt because things are changing fast. As I showed in the beginning, that you know that now AI can write a poem which will take you half an hour or you like. Okay, so that if you will not do, then someday machines will work our. Then sustainability, cost, energy, and social implication, estimation, etc. I suggest that each and every student, PhD student, when he submits the thesis, there should be, if not one chapter, then one section on the cost estimation. Many people say that I have developed a coating, this is the technique, and this one is that, and this is the characteristic, and FESEM, whatever instruments, they don't understand that what is the, I asked many times in interview, what is the difference between SEM and FESEM, faculty positions, and 70% people could not answer that. They don't know that what is FESEM, what is SEM, but it is contained in the thesis. But what they are, but they are just showing the results. They are not doing cost estimation. Because if process has to be feasible, then you have to do cost estimation. So cost estimation part should be shown. Digital manufacturing, that training should be given right from the beginning, and finally hands-on training actually. That is also very important. Not only teaching theoretically, but more something. And then they get development of interpersonal skills. Okay, that also can be given right from the beginning. We take age. So interdisciplinary. So little bit. If I go 2 minutes more, I can just okay. 2 minutes more, okay, fine. So interdisciplinary learning means I am just showing some examples. Like my students are doing that laser farming, bending the seeds and doing so many things by laser. But he has used here that some electromagnetic also, so it is magnetically assisted laser farming. So he has to study a lot of electrical engineering also. That is the type of thing. Unless you study these subjects, then another student tried to do microstructural modeling. So we had to study metallurgy again, material science, and combine it with mechanical. Now the problem is that material scientists, they are not studying mechanical engineering, and mechanical engineer is not bothered about time temperature transformation diagram. But if you want to cope up with the industry 4.0, then you have to do both these things. So you see that he did this type of thing, and finally even phase diagram, and based on that he wrote the code in abacus, so that it can predict the microstructure. So see, he is predicting the hardness after laser processing. What is the hardness predicted by laser, and what is the actual value? This has come by computation. So this type of, it is base version. See, daylight, after night, daylight. I was forced to study that subject in my BTech second year, and then after that I became very happy that I did not have to go there about after night and daylight. What is mountain side daylight? I used to confuse, but now if you want to do modeling with computational tools, people are modeling phase fluxes, etc. So my student has done this one. And then about sustainability also. Sustainability means energy input, amount of CO2 input, digital manufacturing. That means you do the process, but you make the digital part also. Now digital, about this again I want to touch, not for the senior participants or young participants. I will again say that I am seeing lot of thesis. In fact, I requested Vishal ji to arrange my one session, maybe something about 2-3 hours, in which I should teach that how to write the PhD thesis, because many times I have to send it back and then it is again, I hope you will under this one revision. And why it is happening? Because students, so many things have come and they incorporate, but they do not understand. For example, I will not answer this, but I am sure that young people, you are using this one simulation. Now it is written S misses. S misses means basically is plus 1 misses. Okay, but it is written average 75%. What is the meaning of 75%? I asked them, and more than 75% people said that they don't know. That is it. So what happens? And it is a very simple thing. I can tell in 2 minutes if they have will, but it seems that they are not having will, and this is so simulations. So I am just putting a caveat that if you want to do simulations, you as a teacher, it is your responsibility that they understand each and everything. New tools have come which were not in my time. Many of the tools, they have come, Raman spectra, etc. We never thought that Raman spectra will be done by mechanical engineers, but now mechanical engineers are doing Raman spectra. But then you can at least tell that they should know the theory behind that, how it is done. So hands-on training. You see, I did this type of work, you always you can take, my training students, BTech training, they made this type of models actually, using by twice type of things, so that they know that things go inside. This is a kind simple cantilever beam. In one model I have made, you can show many things here. That what is the effect of the cantilever beam and what is the effect of the vibration on the length actually. So you know that this is a siphon coil, that we can use siphon. There is a ball, and if you put water level will keep rising as it goes at the lip of the ball, that puppet, then the water comes from bottom. And then you ask the student how it is done. So if I don't show this mechanism, they think that there is some valve and hydrostatic pressure increased and the valve got opened. I said it will be very complicated that way. It is a very simple thing, and this is siphon coil. So many of such type. I said the students, why you purchase items from outside, companies give you mechanism. I said you make simple making linkage and mechanism is very easy. You just need some strips like this is phosphate sheet and make that. This is a simple device for measuring coefficient of friction. Okay, and then this is also one of leaf cutting. Because you are in machining area. Okay, so I made it by this is a real wax, and it just cuts like metal. You can show continuous, discontinuous chip by this type of model which I made here at IIT Guwahati. Then recently in COVID time, I developed that some arrangement for this one ultraviolet radiation. That so many people said, but I said that is not enough. You have heat also. Heat is the ultimate that thing. So I made arrangement which gives heating and also ultraviolet rays. But later on, I thought that like a businessman, after COVID is over, nobody will give importance to this. So I converted it into a pedagogical gadget. So in that gadget, I can do lot of experiments. These are the pedagogical gadgets, and in fact, NIT Agartala purchased 5 components, 10 components actually. Each one is costing 2,500. So if you are also interested, you can also purchase here. And now I hope you have interpretable skills. And NIT particularly, but even for your satisfaction, you may say that okay, NIT is involved in Andhra Pradesh, one private engineering college, that college also purchased 2 units. I am not doing any marketing actually, I don't have time. So that means in that gadget, I can show 5 good experiments on heat transfer. Each unit student can do the experiment in his hostel room, and they can plot the data, they can do many things, and associated video is also available, which will be given free of cost to those people who will be interested. So this is an example of not only my skill, but also it is the example that the same product can be used for 2-3 purposes. It was developed for fighting COVID-19, but it was used ultimately as a pedagogical gadget actually. So these are some thoughts which I shared. So if there are any questions, I will be more than happy to answer. I think that how much time I give you with feedback. I think 15 minutes or what?
You need to realize that time, sir.
No, but still it is this one 35 or how much time I give? That is okay, fine, okay.
Now, the house is open for discussions.
Yeah.
If there are any questions, you can ask.
Any question or comment?
Sir,
Yeah.
3D प्रिंटिंग में जैसे 2 डिफरेंट बॉर्डर को हम प्रिंट के लिए यूज करते हैं,
yes.
तो उसका थर्मल ऑफ कोफिशिएंट ऑफ एक्सपेंशन जो होता है वो डिफरेंट होते हैं,
yes.
तो वहाँ पे जैसे डेवलप्स आने के चांसेस रहते हैं, तो मतलब किस तरह से पाउडर सेलेक्ट करें, कोई रेंज है उसका कोफिशिएंट ऑफ डिफरेंट एक्सपेंशन का, मतलब डिफरेंट कितना होना चाहिए?
yes, yes, yes. नहीं, इसमें ये इशू बहुत इम्पोर्टेंट है, बिकॉज दोनों का कोफिशिएंट ऑफ एक्सपेंशन डिफरेंट होगा, उसके लिए भी कुछ टेक्निक्स है, उनको अडॉप्ट किया जा सकता है। जैसे आप टेम्परेचर को भी मैनिपुलेट कर सकते हैं ना, जैसे उसका डिफरेंस रेसिडुअल स्ट्रेस क्यों आते हैं, इट इज नॉट ओनली बिकॉज़ ऑफ द कोफिशिएंट ऑफ थर्मल एक्सपेंशन, जैसे उसमें अल्फा एक फैक्टर है, अल्फा इनटू डेल्टा टी, ओके। तो अगर आप समहाउ ऐसा कुछ कर सकते हैं कि उसका टेम्परेचर डिफरेंट कर सकते हैं, जैसे एक ने किया, दूसरे का टेम्परेचर डिफरेंट है, मतलब कई लोगों ने ऐसा करने का कोशिश किया कि सपोज दे डिपॉजिटेड, और दूसरे पाउडर को जब उन्होंने डिपॉजिट किया है, वहां उन्होंने कुछ कूलिंग सिस्टम डाल के ना उसका वो चेंज कर दिया है टेम्परेचर। तो ये बहुत बड़ा इशू है। दूसरी बात है, उसके बाद हीट ट्रीटमेंट, हीट ट्रीटमेंट एंड जनरली द कोएफिशिएंट ऑफ थर्मल एक्सपेंशन शुड नॉट बी टू डिफरेंट ना, उसका डिफरेंस होना चाहिए विद इन 5% में टॉलरेट कर सकते हैं। सपोज इट इज मोर देन 5%, तो रेसिडुअल स्ट्रेस नॉर्मल केस में आएगा ही आएगा ना। उसको करने के लिए बहुत सी टेक्निक्स हैं कि उसको मिटिगेट कैसे कर सकते हैं ना, या तो हीट बेस्ड, जैसे कोल्ड मेटल ट्रांसफर बिल्डिंग मैंने बताई ना, इसका एक एडवांटेज ये भी है कि उसमें जो है रेसिडुअल स्ट्रेस भी कम आता है। कोल्ड का मतलब ये नहीं कि कोल्ड प्रोसेस होगा, कोल्ड रिलेटिव सेंस में है, दैट मींस उसका टेम्परेचर नॉर्मल टेम्परेचर से कम होता है। जैसे नॉर्मली टेम्परेचर सपोज आपका 700 पहुंच गया, तो इसका जो है 300 ही पहुंचेगा, तो उसको कोल्ड मेटल ट्रांसफर कहते हैं। तो ये ऐसी टेक्निक्स भी अडॉप्ट कर सकते हैं। और अगर वो बाइंडर जेटिंग टाइप की टेक्निक है जिसमें एडहेसिव है, तो वहां पर रेसिडुअल स्ट्रेस नहीं आएगा ना, क्योंकि कोएफिशिएंट ऑफ थर्मल एक्सपेंशन का हीट बेस्ड प्रोसेस में आएगा ना। तो ये चूज करना है कि कौन सी प्रोसेस मुझे चूज करनी है। कोई प्रोसेस है इसमें हीटिंग का कोई काम नहीं है, जैसे 3D प्रिंटिंग एडहेसिव बाइंडिंग टाइप, इसमें एडहेसिव होगा व्हिच विल जॉइन दैट।
तो फैब्रिकेट करने के बाद भी उसका लिमिटेशन हो जाएगा।
तो फैब्रिकेट करने के बाद अगर फिर भी कुछ है तो उसके लिए हाइब्रिड प्रोसेस, दैट मींस आपको पोस्ट प्रोसेसिंग करनी होगी। पोस्ट प्रोसेसिंग के कई मेथड हो सकते हैं। एक तो हीट ट्रीटमेंट होता है, उसमें हीटिंग करना है तो स्ट्रेस रिड्यूस हो जाते हैं। अभी हमने काम अभी किया भी है, जैसे कि उसको हीट किया, देन उसके बाद अनीलिंग किया, अनीलिंग करने के बाद उसका टेम्परेचर मतलब उसमें स्ट्रेसेस काफी रिड्यूस हो जाते हैं। अनीलिंग जैसे एल्युमिनियम था, ये Ti64 वाला एलाइड ना, टाइटेनियम एल्युमिनियम एंड वेनेडियम, तो इसमें क्या किया गया कि उसको 800 डिग्री पे हीट करके 1.5 आवर सोक किया गया। सोक करने के बाद जब हमने उसको देखा तो उसमें जो है उसमें स्ट्रेसेस काफी कम हो गए थे। एक तो ये चीज है। दूसरा ये है कि मटेरियल फार्मिंग बेसिकली कर सकते हैं मेटेलिक ऑब्जेक्ट में, जैसे शार्प पीलिंग वगैरह का भी यूज कर सकते हैं। शार्प पीलिंग उसको हैमर से स्ट्राइक करना बार-बार, तो ऐसे कई मेथड्स है। मतलब पोस्ट प्रोसेसिंग में ध्यान देना होगा।
We can try buttering also.
Yes.
Sandwiching one material in between two materials.
In between two materials, yes. So gradual decrease, yes. So वो भी एक yes gradual. That's what he's feeling. Abrupt change in the coefficient of thermal expansion वो avoid करना है, तो आप बीच में intermediate material भी दे सकते हैं, ऐसे भी हो सकता है। कई options हैं, उसमें case to case देखना होगा। Okay. So anything, yeah. Anything else? Okay. Fine. Yes.
So we are grateful to Professor Dixit for enlightening us with some of the contemporary technologies and emerging areas of research. It is always a pleasure to listen to you, sir. Thank you so much for your valuable time. So the participants, we shall be moving toward the technical sessions, the offline technical sessions. So as per schedule, you will move to your respective rooms.
चले ऊपर कितने सुंदर मैं तो भाई अपना काम करके देना पड़ा भाई तुम कॉल देखी ना नोट नहीं करते किसी को तो रही है एक की नहीं है
वहाँ पे बैठे हुए थे सुबह मैं
रोज का नहीं बुरा तो चलाते नहीं टू व्हीलर बुरा तो बीटेक में चलाता बुलेट सिल्वर कलर चले सुमेश जी चले
हमारे लिए भी नौकरी दिलवा दो यार कंप्यूटर साइंस वाला
Session 1A will shortly start in this venue and session 1B will be held in the LKN hall top floor. I request all the participants please move for the next session 1B in the LKN hall and 1B will be held. We have two sessions are in parallel. These are the two offline sessions.
एक दिन एक दूसरा ने काफी दिन रोजे वाले
ठीक है सर हाँ ठीक है सर
अच्छा वो तो दे दो
कोई नहीं
हाँ नहीं वो एक बैंड ऑफ हो गई ना हाँ इधर मेल भी जो कर मेल मेल पॉइंट सारा काम नहीं होता एक्चुअली अपने आप सब कुछ अटैच है उसकी बस एज पीसी चलाना है जो मर्जी ये मार्केट
technical session once age offline वो यहीं पे रहेंगे और एक वीडियो भी कर आप बता देना जब प्ले करेंगे वीडियो प्ले होगा candidates paper ID 1077 1760 1560 2503 that is इनकी प्रेजेंटेशन यहाँ पे होनी है प्लीज पीपीटी अपलोड करवा दें
कुछ नहीं बचे बच्चे से नहीं कॉलेज कल दा पार जाको हाँ जी सदा
आपका भी किसी का चार्ज हो गया
12 मई तो अच्छे से गई हाँ हैगा अभी तो तेरी कौन सी पहले बंद कर और किसकी
अपलोड करवा
मनी करना पैक अभी करते सारा कुछ छेती हाँ माइक में रख ला फटाफट
I think C is
हेलो हाँ जी ऑनलाइन सेशन की तो सेशन ऑनलाइन है वो तो फुल कॉपी करना है रोहित सबको कुछ लाइव स्ट्रीमिंग ऑफ करा दिया बस 10 मिनट खाने की निकालता है भी कैमरा में वो तो सिर्फ आपको आप चलते रहने का लिंक जिहदा लिंक है तो उन्हें खोलना होगा और तो ਉਹਦੀ स्विमिंग होनी नहीं ਉਹ पॉइंटर पॉइंटर वो मेरा वो
और बताओ इसकी तीन आई है आपने देखी आपकी आईडी क्या पेपर है 156